Seislaw from NASA's Office of Communications, and we're here to discuss.
Okay, we're back. Here's the press conference, and we have the combination
to tomorrow's launch attempt. We are targeting tomorrow.
So this is the Crew 11 press conference.
PM for Eastern Time for liftoff to the International Space Station. Once there, the crew of 4 will maintain the orbiting laboratory and take part in experiments and research.
I got to
Joining us today to talk more
quick.
about the pre-launch activities and some of the reviews that took part today. We have Ken Bowersox, Associate Administrator for NASA's Space Operations Mission Directorate, Steve Stitch, Manager of NASA's Commercial Crew Program, Dana Weigel, Manager of NASA's International Space Station Program, Sergei Krikalev, who is the Deputy Director for Human Spaceflight with Roscosmos, and Naoki Nagai, Program Manager of the International Space Station for the Japanese Aerospace Exploration Agency, or JAXA. And joining us remotely by phone, we have William Gerstenmaier, the Vice President of Build and Flight Reliability at SpaceX. We're going to have opening remarks in just a minute from our panelists, and then we will take questions from reporters here in the room and on the phone lines. And a reminder to the reporters on the phone lines, *1 will get you joined into the queue, and *2 if you want to leave the queue. And with that, I'll hand it to you, Ken.
Thanks, Steve. Hey, welcome everybody. Thanks for being with us here today. We really appreciate your interest in our work in low Earth orbit, where every day we're building the knowledge base that will take us from the surface of the Earth to low Earth orbit, out to the moon and onto Mars. And while we're doing that, we're gathering knowledge each day that benefits us here on the surface of the Earth. I was really happy to be able to meet with the Crew 11 team here earlier today. Both Zena and Oleg are first-time flyers, and Camilla and Mike are experienced veterans, but they were all really excited about having the opportunity to go up and visit the International Space Station. I think the rookies were probably most excited, but the experienced folks are ready to go too. The last couple of weeks has been really busy for our whole team, our commercial partners, our international partners, representatives from our ISS and commercial crew program. The work was summarized last Friday at a flight readiness review where we all got together, looked through the results of all the different reviews across the agency preparing for this mission. Then across the weekend, we had a flight readiness or a static fire in preparation for the flight. Then today, we had a launch readiness review where we went through all the different exceptions that had come up prior to the review.
Turn the volume up.
And made sure that everybody's ready and focused for the launch here in the next 24 hours or so. It's so impressive to watch our international and commercial government team work as they prepare for a mission. They focus on the work that needs to be done, and their priority is flying the mission safely. I'm so eager to see this mission launch, but as always, we launch when we're ready. With a little luck, we'll see a launch soon, and we'll also see a crew come home soon. But be patient with us. Let's make sure that the vehicle's ready to go, and that our team is really certain before we hit the button. And now I'd like to pass it over to Steve Stitch so he can share more of the details.
Thanks, Ken, and it's an honor to be here representing the commercial crew team, and really appreciate your interest in human spaceflight. Today was a big day. As Ken said, we had 2 big reviews, our launch readiness review with SpaceX, and then following that review was the Dragon mission management team. Our NASA team has been working side by side with SpaceX for this whole flow, but in particular really closely over the last 2 weeks. And the NASA
Steve Stitch runs the commercial crew program, so that's the Starliner and Crew Dragon program.
into the countdown early tomorrow morning, about 8 hours prior to launch, and press up the COPVs on the composite overwrap pressure vessels on the Falcon 9 and get into the countdown. As Ken said, the launch is really close to noon, 12:09 p.m. Eastern tomorrow on Thursday. Sets us up for a docking. It's a little longer phasing than we typically have. It's about 39 hours of phasing from launch to dock. That's just the way the orbital mechanics works out for this particular opportunity. And we would dock Saturday, August the 2nd, right around 3 a.m. Eastern time. We have backup days on August the 1st, the 2nd, and the 3rd. And those have various docking times associated with them. So we're in a real good sequence of opportunities right
Ken
now.
runs the ISS.
The weather is looking really good for
He's a
tomorrow.
ex-shuttle astronaut.
The launch weather, only a 10% probability of violation. We're early in the day, and so there's really not much of a chance of any precipitation or showers here at the Kennedy area for the launch site. The abort weather also looks very favorable tomorrow as well, with winds and waves all along the ascent track being within limits. We'll watch showers or thunderstorms, potential forecast of those in the staging area. We'll watch that very carefully. And then a little later in the week, the weather gets a little bit worse. Still good here at the Kennedy Space Center, but along the ascent track, we'll have a frontal boundary that'll be there. And so the winds and waves will come up. And so that's why really tomorrow is our best opportunity. Gerst will talk more about it, but we had the dry dress on Monday where the crew got into Dragon, put Dragon through its paces. Really didn't have any issues at all with Dragon. Of course, static fire was aborted at 57 seconds due to a ground sensor problem that Bill will talk more about. And so we moved the static fire one day later, and we're in the process of finishing all the reviews for the data from that static fire, which happened yesterday. So far, all the data looks good from the vehicle. Bill will talk more about it, but we had to R&R replace one of the engine controllers on engine 5. It had some anomalous signatures, and so we replaced that. We've checked that out, and it's good for flight. As you know, this is a really important mission for us. It's our 6th flight of Dragon Endeavour. We worked very hard with SpaceX to complete all the reuse activities for this vehicle. We had certified the vehicles, the Dragons, for only 5 flights, and now we've completed all that work, and we're really ready to go.
When did this happen?
Pretty clean static fire, really nothing other than the R&R of the engine controller we're working on. Bill will talk more about that. I really want to thank the NASA and SpaceX team for all their hard work.
6 flights.
From the agency FRR, which was held on Friday, July 25th.
I know what it is. I watched the launch.
We had a couple of exceptions coming out of there. One was what we would call a non-standard open work on Dragon. Our team focused a lot on the reuse, and so we had a few items to go through and close out. And then we wanted to take one look at the launch pad. There's a tunnel that goes out to the launch pad. There's a couple of high voltage electrical lines that go to the pad. We wanted to inspect those based on some work that was done on the roadway above, and all that checked out just fine. It was great to interface with the crew recently. You can tell the crew they're excited, they're ready to go. In particular, Mike Fink was our commercial crew program rep for many years when we were developing Dragon and Starliner, and so for us, it's just a real exciting time to see him go fly. Once we get docked, we'll have a shorter handover, and Dana will talk a little bit more about that. The first set of undock opportunities for Crew 10 would be on the 6th of August. We have done an inspection of the Dragon vehicle. We look at the thermal protection system. We've gone through and inspected that vehicle on orbit, and it looks really good to come home. But we obviously have to get Crew 11 there docked safely first. In closing, it's great to be here today. It's really exciting to get into our 12th launch with commercial crew. And I can't thank the team enough. They've worked extremely hard to get through all this reuse. It's been a busy year for us in commercial crew, swapping capsules back on Crew 10, and then now with the reuse work. I'd like to also thank Dana and the ISS program, our international partners, all the agencies here in the country that work with us, United States Coast Guard, the Space Force, and the entire team. And with that, I'll hand it over to Dana.
Thank you very much, Steve. Let's see, and thank you all for joining us today to learn more about the Crew 11 and the ISS mission.
Oh, dude, Crick is there.
For a launch on July 31st, We'll have a docking at the Node 2 Zenith port, and as Steve said, that'll be August 2nd around 3 a.m. Eastern Time. We're looking forward to the arrival of Crew 11 with NASA astronaut Zena Cardman and Mike Fink, JAXA astronaut Kimia Yui, and Roscosmos cosmonaut Oleg Platonov. This will be the first space flight for both Zena and Oleg, the fourth for Mike, and the second for Kimia. But this will be the first time that any
Tomorrow
of them
at
has
noon
flown
time
on a
for us.
Dragon
Basically my normal start time.
vehicle. And this morning when I saw them, they were all smiles, really excited and ready to leave the Earth. Let's see, once Crew 11 gets there, we've got 3 full days of handover between our 2 crews. They'll cover safety critical items, review procedures on board, and they'll do a little bit of ISS familiarization.
That's Dana Weigel. She does ISS logistics.
Being August 6th,
Basically
Johnny
runs the
Kim,
ISS
who's been on
program,
board
so
for a
Kim.
few months, will continue that handover and familiarization with Crew 11. Crew 10 has been pretty busy on board this month. We successfully completed the Axiom 4 private astronaut mission and just splashed down a couple weeks ago on the West Coast. They've also been busy
I'll answer
doing
in a
some work
second.
on board repairing some life support systems. We had some faulty components that had to be replaced in our water processor assembly and with the toilet that's on the U.S. segment.
What's with the toilet's not working?
Now that we've done that work, that puts us in a great configuration on board to accept the additional crew that we'll have with us for handover. It's not fun not having a working toilet and having this many crew members sharing one, so we're happy we have that back. Let's see, looking ahead, we have a busy fall in front of us, a lot of flights and a lot of activity for Crew 11. August 21st, we're planning to launch the SpaceX 33 cargo resupply mission. That's a unique flight for us. It's carrying a reboost kit in the Dragon trunk. That reboost kit has a number of propellant tanks and thrusters, and it will be used to do altitude management and reboost on space station between September and December of this year.
Cool.
And that helps us because we have a joint goal to conserve and store propellant on the Russian segment to kind of build up our supplies there. Shortly after that, middle of September, we've got the Northrop Grumman or NG-23 mission. We accelerated that flight to help with resupply at a station. That was in response to Northrop finding spacecraft damage for their NG-22 vehicle and realizing that we can't fly that this year. And then in mid-October, we've got a new cargo vehicle flying, the HTV-X. That is a vehicle built by JAXA. It has a lot of cargo carrying capability, and we're really excited to have that as part of the cargo resupply fleet for station.
Hey, Matthew.
As you may know, this year marks a huge milestone for space station operations. In November, with Crew 11 on board, we'll be celebrating 25 years of continuous human presence on board the space station. Once Crew 11 gets there, we will have had 290 people visit space station from over 26 different countries. Over those 25 years, we've had some remarkable achievements. We've advanced science in many different fields, and we've developed critical technologies that will help us do longer spaceflight missions as we work towards our lunar longer duration missions and also missions to Mars. The research and the commercial development that we've done on board space station have also laid a foundation for being able to do commercial low Earth orbit destinations in the future. I'm looking forward to the launch, to having Crew 11 on board, and to seeing the amazing things that they will accomplish during their expedition. And with that, I will hand it over to Sergey.
So, dude, this guy that's about to talk, that's Sergey Krikalev. That guy's a legend. He's one of the craziest people that have gone into space. He was on Mir when the Soviet Union collapsed. And then he did Shuttle Mir program. He did ISS. Guy's awesome. What a freaking legend.
This morning we met the crew. They're in good mood. They're ready to fly. And Oleg Platonov, our cosmonaut, is flying on board of this mission. It's going to be his first flight. But we know that he is in good hands. And Mike Fink already flown 3 times, and 2 of them was on Soyuz spacecraft. And he actually veteran of ISS mission. During these 25 years, he was on the station several times. And I know that this crew is very capable, and we are sure that they will be successful flight, docking, and good operation on board. I know that previous crew, and our cosmonaut is also a part of previous crew, Crew 10. They are waiting for this flight because they know that when this flight arrives, it means that time for them to go back is going to be very soon. I think what is important that we continue integrated crew operations because safety of the crew and reliability of the program is very important for us. We are working together. We are working together not only in space but also here on the ground, providing cargo delivery, managing supply on the station. But everything is done to have successful missions, and integrated crew is part of it. And Dana is mentioning one anniversary of what is going to be this year, and another anniversary we celebrated a few weeks ago, 50th anniversary of Apollo-Soyuz mission. We started to work together many years ago, and we still continues. With that, I give the floor to you, please.
Thank you for introduction. My name is Naoki Nagai. I'm a JAXA ISS program manager. First, I would like to express my appreciation to NASA and the Commercial Crew Program and the SpaceX and all our colleagues for their dedication to the Crew 11 launch preparations and the continuous ISS operations. This is my honor to be here to speak for a flight tomorrow. Now, as preparation proceeding for launch and return, JAXA is also undertaking all the necessary preparation for JAXA astronauts Kimiya Yui and Takuya Onishi on board. This mission marks the Kimiya's second expedition since his 2015, and with a deep desire to give back to all those who have supported him. He has thrown himself into his training for flight with guts and hard works. During his stay in ISS, Kimiya will carry out a variety of experiments and technology demonstrations. For example, he will carry out a demonstration mission for a more compact and efficient carbon dioxide removal system, which is expected to play a key role in future exploration, Gateway or the pressurized rover on the moon. He will also work toward advancing scientific outcomes and expanding the commercial use of space activities towards the post-ISS era. During his stay, there is another big event. Kimiya captured Japanese cargo vehicle HTB, we call Konotori number 5, at the last flight. But this time, we call HTB-X. That is a new next-generation cargo vehicle. It's scheduled to launch within his stay. I expect him to play a key role in its capture and operations again. Lastly, in this mission, Kimiya will be welcomed to ISS by astronaut Takuya Onishi, who currently serves as the ISS commander. It will be a short moment, but this will be the first such experience in 4 years that 2 Japanese astronauts will be on board ISS at the same time. I believe this dual presence is a result of Japanese continued contribution to ISS operation, almost a quarter-century human presence, and the Kibo 15 years operation successfully.
Cool.
And also the close relationship with international partners here. For the Japanese people, this is seen as a powerful and symbolic moment representing the advancement of science and technology. And also, I believe it will be a moment when we feel closer to space than ever before. It will surely inspire dreams and hope in the Japanese children who will lead the next generation, while also paving the way for Japanese future participation in the Artemis program and beyond. We will continue with the final preparation as we look for the upcoming Crew 11 safe launch and also the Crew 10 safe return. Thank you for today. And I met Kimiya in this morning. He's ready. And we also, in the ground side, is already also ready. So go for Crew 11. Thank you. Back to you, Steve.
Thank you, sir. We're going to go now to William Gerstenmaier.
Arigato gozaimasu, Nagai-sama.
Honored to be here today remotely.
Oh,
we just completed the launch readiness review in advance of the launch tomorrow. This will be our 4th Dragon mission to the space station this year, and our 5th overall Dragon mission to date, which is pretty amazing from a Dragon standpoint. Launch readiness reviews and crew missions are a time for us to reflect and really double check our logic and flight rationale. It's not really the meetings themselves, but it's all the activity and all the detailed review by all the partners, all the team members that look at all the data and make sure we're really ready to go fly, that make sure we're ready to go. And then we do the reviews, and that's kind of the culmination and the wrap up of that data. During Monday's static fire of Crew 11 Falcon 9 rocket, we auto-aborted at T-minus 57 seconds, and that was caused by an error in the transporter erector cradle arm indication. The arms performed nominally. They did exactly what they were supposed to go do, but the abort was caused by essentially a false sensor. We corrected that. We adjusted it ahead of yesterday's successful static fire. That all went well. We also had a chance to use this as a learning experience. We went back and reviewed all our alarms, all our alerts, all our calibrations, all the indications to make sure there was nothing else out of kilter or out of skew that we needed to protect for. I think this all worked as designed on the second static fire, and I think it also showed the value of a static fire. We would not like to have an abort while the crew's on board and we're offloading propellant. We want to make sure that when we go through the countdown, we're ready to launch when we get there. So that static fire on Monday proved to be a very advantageous static fire for us and actually improved our learning and made us even better prepared for the launch tomorrow. The temperatures at the Cape have been pretty warm, and they've delayed some of our static fires slightly. So what we're going to be able to do is we're going to load some of our gases a little bit earlier before the crew gets out there, before we do propellant loading, and that will allow us to essentially have a smoother loading going forward. So we'll do that during the cool of the night. We'll get essentially the rocket ready for propellant load and then do our normal activities. It won't affect the timeline for the crew. It won't affect the timeline for propellant loading, but it'll keep us moving forward. Space flight is really humbling and difficult, and we always need to listen to our hardware, our data, and the real-world lessons to ensure we're really ready to fly safely. Space flight's not tolerant of errors, and we only fly when we're ready. We did extra checks on Dragon. We reviewed the post-flight data from both Crew 9 and Axiom 4. We reviewed the Dragon data and the Dragon interactions with Falcon during the static fire. We looked at all the ground systems and the hardware, including Cape systems. We carefully looked and updated the booster for Crew 11 as the booster last flew on Axiom 4, and that gave us a good chance to see how this booster and engines operate. We'll continue to carefully review activities and double-check everything as we move forward. This is the 6th flight for Dragon, for this particular Dragon capsule. It's comparable to previous Dragons, but, it's also important to note that we're flying several upgrades. We have a new drogue parachute design that is more effective and will help with parachute deploy. We did extensive testing to make sure that that's ready, to make sure the drogues work correctly. We have an improved heat shield structure, which I think you've heard about before. And we also have an improved IVA suit that has more mobility, and Mike Fink will be testing that for us on this flight. So even though it looks like it's the 6th flight Dragon, there's still lots of improvements, still lots of things that we're learning and improving to make things better from an overall standpoint. This will be the 3rd flight of the Falcon 9 booster, which previously launched Axiom 4, as I said before, and a Starlink mission. This first stage booster will also be returning to landing zone 1 at the Cape after it completes its mission of delivering the crew safely to orbit. A static fire, after the static fire, an engine controller failed on engine 5. The engine controller was fine during the static fire, but after it failed, we are an RDAC controller. We've checked it all out. We reviewed the data with the teams and with NASA. The failure signature we've kind of seen before, and we've also evaluated the consequences if this failure were to occur in flight, and it would not have a problem for us if it occurred later in flight. I think the teams are ready to go fly. We'll continue to double-check things and move forward. SpaceX would like to thank NASA and all the partners on this mission, especially Roscosmos and JAXA, for their trust and close collaboration with us as we prepare for this Crew 11 launch. Crew launches are special. We'll make sure we're ready to go fly. We trust our partners, and hopefully our partners trust us, and we'll have a successful flight. We look forward to answering your questions.
Thank you, sir.
Cool. I'm going to skip forward to the questions now.
Hey, thanks a lot. Bill Harwood with CBS, and Sergey, it's great to see you here again. Dana, question for you. Where does it stand in your thinking about possibly having to reduce crew size, reduce cargo flights as part of the reconciliation and budget process here, which is opaque to me, but I'm sure you guys are figuring this out. But is that something that could happen as early as crew 12? Are you looking at going lower than 3 people if you ultimately have to do that? Or are you hoping to keep it at 4 all the way through? And just where we stand.
Yeah, I mean, ideally, we'd stay at 4 crew if we're continuing to do the normal mission objectives that we have on our plate today. With the amount of science and research we do, certainly takes 4 crew. We're looking at a range of scenarios. So as you know, it's very dynamic right now in terms of what we might see in the budget, what we might end up with. So we're looking at the entire spectrum. I think the earliest we would do anything and what we've evaluated is crew 12. We don't have to answer that right now. We don't have to make that decision. We can actually wait pretty late to make a crew size smaller if we need to. In terms of cargo vehicles, we're well supplied through this fall. So in the short term, I'd say through the end of this year, the beginning of 26, I mean, things look pretty normal in terms of what we have planned for the program. But we're evaluating things and we'll be ready to adjust when a budget is passed and when we figure out where we really land.
Next, let's go here on the left side for Will.
Yeah, hi, Will Robinson Smith with Spaceflight Now. Thanks for taking the time to talk with us. Question for Mr. Kirklev and Ken Bowersox. Obviously, this is the 25th anniversary of the space station, and there's a lot to celebrate, a lot of work left to do. But I wonder, as the station is coming to its end, how are the two agencies kind of thinking about the future of cooperation in low Earth orbit once the ISS is ultimately retired? Thanks.
Sergey, you want to go first? Or?
Go ahead.
Okay. First, I learned a tradition from our Russian colleagues that we never celebrate an anniversary before it really gets here, and we still have a few months before we're going to be able to celebrate the 25th anniversary, but we're all looking forward to it. What I'll say is it's very important for us to work together as we reach the end of the International Space Station. The station was built so that it requires the participation of all of our partners, especially Russia and America, to operate it every day and to bring it home. So we will be working closely together to coordinate everything that we do in the final days of ISS and working together to maximize the utility of ISS until we finally bring it home into the ocean. After that, there's still lots of things that we can discuss. Both Russia and America are looking at our own different space stations. The Ross, the Russian space station, we're looking at new commercial space stations in America, and there's lots of ways that we could still continue a partnership going forward if the circumstances allow us to do that. And we've seen the value of working together. It started with Apollo-Soyuz 50 years ago. We've seen the value of strong partners as we work in LEO today, and I think we'll see that there's value in the future. Sergey, anything to add?
I probably will add that 50 years ago, people start to think that if we are flying to space, we need to be able to help each other. And I think if we are going to fly in the future together or in different stations, but we are thinking about being able to help each other in case of necessity of rescue. So
Cool.
there is no final decision, but of course, what Ken already said, that we have to work together to return back station in a safe way, safe mode, and we are working together to provide it right now, because as I said, even managing fuel capacity of the station, cargo capacity, that's integrated crew is working on the ground. So we are working together, and I hope we will work together in future.
Thank you. We're going to take one more question here in the room, and then we will go to the phones and go to the right.
Zoe Rosenstein with NSF. This one's probably for Steve. So obviously 1094 had quite a few issues it was dealing with, the leaks and the TVC on Axiom 4. Have you guys been following that and the solutions that SpaceX did ahead of the Crew 11 booster? And maybe, Bill, one additional question, I'm sorry, was are there any plans beyond this mission to use LZ-1 and 2 again, or will, after that, everything move to the pad landing zones?
Good question.
Yeah, I'll start. This particular booster, since it's assigned to our commercial crew flight, we follow that booster through its entire life. So the Starlink flight that Bill talked about, the first flight, and then the build up to the Axiom mission, we followed the liquid oxygen leak that we had prior to Axiom 2. We swapped out a feed line and a sensor, and we followed that work and looked at the pedigree of all that hardware that was being installed. Also, we had a TVC that was responding in a way that was different than any TVC we had seen in the fleet. We worked with SpaceX hand in hand as they swapped out various components prior to the Axiom 2 flight, or Axiom 4 flight, and then also we swapped that entire engine out because there was a lower wire harness that SpaceX wanted to take a look at. So we followed all that work. So we have followed the pedigree of this booster all the way, starting with its build at Hawthorne, its testing at McGregor, and every single flight. That's just the way we handle every single mission to make sure we're really ready to go fly. And so partnership with SpaceX has been great, even up until replacing this common controller on Engine 5. We worked with SpaceX hand in hand as they swapped that out and checked it out. So, and I'll let Bill answer the next part of the question.
Yeah, can you hear me?
We have you.
We have you.
Okay. Prior to Axiom 4, we ensured that we had fixed both the oxidizer leak that showed up, and we also ensured that we had fixed the TVC problem. What's really neat about this partnership was NASA could kind of watch us as we prepared and fixed both of those problems. So they got to see us work in real time to get both of those problems fixed and then go fly. And as you can see from the Axiom 4 flight, or the evidence of it from Axiom 4 flight, was those worked perfectly fine. They worked extremely well. But we learned a lot from both of those. So then NASA can then see those as we go into this next flight. So again, I think that teaming relationship between NASA and the second set of eyes are really good, and really helps us to kind of, keep improving. And there's a tremendous advantage of us flying more flights. We fly a lot of Starlink flights, we fly the Axiom flights, et cetera. And every one of those flights is a chance for us to learn. And when we can learn something and then provide that back, we can actually provide more reliable cargo and more reliable launch for the crew missions that come up. So, again, I think that activity has been extremely well followed, and we have very solid rationale for both of those and the new problems that have arisen. In terms of landing, this will be our last landing on Landing Zone 1. We then plan to retire Landing Zone 1, but we'll still continue to use Landing Zone 2 at the Cape.
Thank you. We're going to go over to the phones now. Reminder for those on the phones, *1 gets you into the question queue, *2 takes you out. And we're going to start with Marcia Dunn.
My question is for you, Sergey. I was hoping you could provide an update on the space station air leak on the Russian side of the space station. Is it still there? Is it better or worse than before? Do you have any repairs upcoming planned? And what's your latest on what may be causing this leak? Thank you.
Leak still continues. We keep searching for the leak and repair the leak. And recent repair actually reduced leak rate significantly.
Yeah.
For the period of time, we were even thinking that we finally found the last crack and repair it, but obviously on a long period of time, we see that leak still continues, but it reduced significantly. And most important, we are working together with specialists, and we brought together engineers and scientists from Russian side, from US side, on cracks propagation, on intergranule corrosion, all these scientists are working together to find the root cause of this crack. It's important for all of us for the future design, for future station, to be sure that we will not have a similar situation in the future. But for now, we are managing to keep crew safe. We developing together procedure how to deal with it to be sure that crew is in safe configuration when we do all these repairs.
And next we'll go one more to the phone, then come into the room. Kenneth Chang.
Hi, thank you. This is for Steve Station, maybe Dana Weigel. So at one of the last news conferences, you mentioned that you might be extending the crew rotations from 6 months to 8 months, but that was pending finishing a certification of Dragon for 210 days. And could you give us an update on that?
Yeah, I can start, and then I'll let Dana add. Yeah, we are looking at extending the duration of the dock duration for Dragons to get the missions to be a little longer. We completed all the certification work for Dragon reuse, and now we're starting to get the data in from SpaceX on what it would mean for the vehicle to be in orbit a little longer. And so it'll take us a couple of months to go through that data. And then once we do that, we can extend the duration per whatever Dana needs if we need the 8-month mission. We've done some work already in this area. We had a 7-month mission already on Crew 9. So we don't think there's anything that would stand out, but we want to go double check things like leak sizes, seals in particular. The paint will degrade a little bit over time. The paint's important to keep the thermal properties of the vehicle where we want them to be. We want to go double check that, and there's other items we'll go double check for their life. Fans will run a little bit longer. The structure will be subjected to a few more thermal cycles. We need to go through all that data. And once we do that, then we can step up to the 8-month mission per whatever the ISS program needs.
Yeah, I would just add that we're looking at that right now for the Dragon flights, and so we are looking at the potential to extend this current flight, Crew 11, and as Steve said, there's a few more months worth of work to do first. We are not talking about extending or changing the duration of our Boeing flights at this point in time. We've got enough experience with Dragon that we're at a good point in time to do that with that vehicle.
Thank you. And coming back here into the room, we're going to go to Miles.
Hi, thanks. A question for Steve Stitch, Miles Dorn with CBS News. The reduction in workforce at NASA that we've all been hearing about lately, what does that look like specifically within the commercial crew program? How has the program been impacted by that? And how is this going to impact the number of people that you have available who can do the inspections and product assurance actions of the commercial providers?
Yeah, very good question. So first of all, for this flight, I would say we have had our entire team. Most people that have chosen to take the deferred retirement program have decided to extend a little longer to get through this particular handover. Overall, we'll be looking at in detail the people that have decided to depart us. I would say this flight for me is a little bit bittersweet because every person that's decided to retire, some were going to retire anyway and have decided to take the deferred retirement program. Some have decided to leave a little bit earlier. And so every single person, I think about their contribution to the program over the last 10 years, getting us to flight with Starliner, getting us to flight with SpaceX and Dragon. And so you look at every person, to me, it's personal and it's individual. It's also personal and individual for those people. You know, they've made a choice. And so we'll have to look at the workforce going forward. You know, one good thing about Dragon is a lot of the big upgrades, we have gotten through those this year. We're moving to the West Coast landing, and that work is behind us, all that certification work. Gerst mentioned the fact that we have a new heat shield structure. We've gotten through that certification work, and that's behind us as well. The new drogues are a little stronger. Their deployment is a little more orderly. We've gotten through that work. So we've gotten through a lot of the big things on Dragon, including the 15X reuse or the extended Dragon reuse. So for us, we'll be looking at that and then looking forward to Starliner and then talking about how we move forward. I'll see what Dana has to add.
Now, I would just say, you know, we're in a similar situation with space station. We have years and years of expertise, which is great. But on the other hand, when you lose folks or folks choose to leave before the end of the program, it's really hard to rebuild some of that expertise. And so we are tracking along closely with our teams. You know, we fly every day. Even though we're not launching every day, we have humans on board every single day. Every single day is critical to us. And so we keep our team focused. We keep our eye on the target and make sure we're working the top priority issues. At the same time, we're trying to help the workforce through this challenging time. And in some areas, it's actually opened up opportunities where people have wanted to try something else and they've moved around. And so we're keeping our eye on that and really making sure we're making the best use of the skills and the talent that we have on the team.
Thank you. We're going to the phones next, and we're going to Micah Maidenberg.
Yes, good evening. Bill, you had mentioned in your opening remarks about doing some extra checks for Dragon. Were those checks extra relative to earlier flights, and were they prompted by anything in particular or just some of the new hardware and firsts for this mission? Thanks.
There was a combination of both. In cases of some of the thermal protection system, we saw some things on orbit that with both Crew 9 and with Axiom 4 that we wanted to check. So we tested those on the ground extensively before the vehicle returned. And then we took learning from that and we changed the way we built the hardware to make sure that those problems wouldn't occur on future vehicles like Crew 11. So we learned from those previous in-flight things we saw on the previous missions, and then we upgraded for Crew 11. And then we also did a significant amount of testing to ensure that, like, for example, the new drogue chute system we're going to use for this Crew 11 flight, we tested it with a rocket sled to make sure that it would actually deploy correctly. We used that testing to go re-look at some basic design things in the parachute system, and we learned some lanyards could be changed a little bit, and we're going to improve those in going forward. So again, I think the advantage of continuing to learn and continuing to make changes is you get a chance to go back and take a look at your hardware again, look at it with a different set of eyes, and sometimes it helps that maybe a newer engineer gets to look at something that someone else had done before, several years before, and they find some weaknesses in the analysis, and then we get a chance to go either test, validate that analysis, and improve. And I think that's a way you can keep flying reliably and flying safe, is just never assume that the vehicle is ready. You don't get complacent. You continue to keep looking, keep trying to find ways to improve, and continue to test and check and challenge your assumptions you've made before, and just don't assume they're correct. Use the data to drive you in the right direction to make sure your vehicle is really reliable and ready to go fly.
Thank you. And next we're going to go to Stephen Clark.
Hi, thank you for taking my question. Stephen Clark, Ars Technica. Most of my questions have been asked, but I'll take the opportunity to follow up on a question that Gerst answered earlier. What's the long-term plan for LZ-2? Is that going to be retired at some point in the near future or medium-term future as you move those landing pads over to Slick 40 and 39? Thanks.
Yeah, I don't have the exact details of that, but I think we'll use it for the interim here, and then we'll figure out the right time to go move. But we want to return to landing site is a very important capability for Falcon. It saves us the drone ship operations and all the activity associated with catching the booster on a drone ship and returning it. So we want to keep return to landing system capability at the Cape, and we can get you the details of the exact plan for that handover. But we're working with the Cape and with the Kennedy Space Center folks to figure out the right time to make that transition from landing zone 2 to future. But I think we'll stay with landing zone 2 at least near term for a little while, and then look at the right time to move to the other areas.
Thank you. Coming back into the room for the next question. Going to take Will.
Hi, thanks for allowing a second question. This is to Steve Stitch. A crew assignment question, if I may. Zena Carbon was pretty quickly reassigned after the shift from Crew 9 to Crew 11. Has Stephanie Wilson also been assigned a mission, and if so, which one? And then secondly, a couple of the folks that are flying on Crew 11 are coming over from Starliner 1. Is there a chance that they, since they have the experience with the Starliner, could be reassigned to that mission again in the future, or would Starliner 1 be a whole new crew with, whether Scott Tingle and Josh Kutrick are still in the loop or not? Thanks.
Good question.
Yeah,
we like
boy,
Bill. Bill's cool.
I've been so focused on Crew 11, I haven't thought much about crew assignments. Would have to get back with you. I'm not sure Stephanie's been assigned yet. I don't really know her status. Mike Fink will go fly this flight. If you just think about it, he'll be on orbit for a while, probably landing in the March timeframe if we extend the flight to 8 months. So hard to say whether he would be on a Starliner 1 or subsequent flight. Those flight assignments, we're still working them out with Starliner. So.
And we're going to go back to the phones for the next question, and that's going to be Ken Kramer.
Hi, thanks for taking my question. We're not there, unfortunately, but we wish you Godspeed and good luck. My question is for Sergei Krikalev. I'd like to know, what has Roscosmos decided about post-2028 operations? I think that's when you're ending Russian operations. But are you thinking about continuing beyond 2028, or are you thinking about commercial stations for Russia? If you could tell us a little bit, would be great. Thank you.
Really, we approved from our government to continue nominal operation till 2028, but it doesn't mean that we are going to abandon station at this time, because nominal operation probably will stop if we wouldn't extend our nominal operation. But anyway, even if we stop nominal operation, it will mean that we need to start deorbit procedure. And working together, we found a profile of deorbiting, and it actually takes about 2 years. So at minimum, we are going to work together until we return station safely back to ocean. And it's going to be not earlier than 2030. It's not supposed to be nominal operation, because the orbit operation is little different, but we think that we would be able to continue manned flight, continue expeditions on the station up to a certain point. And a lot of things will depend on the reliability of the station, because every day we are flying, we keep testing the station, and we studying, learning how long station actually can work. So it will depend on status of the station and technical conditions of the station.
Thank you. And just going to poll the room one more time for our last question. Let's go to Bill.
And Sergey, another question for you, and just because we'd love having an opportunity to ask you the question, things we read about the Russian segment, are filtered through newspapers and translations, and it's hard to ever get specific data that we know is real or whatever. But with regard to the leak, do you have is there any way to tell us how much air escapes through these leaks? Is it a pound or two or a kilogram or two per day, or we don't have any idea what the leak rate might be? And if you know it off the top of your head, thanks.
Much?
0.1 kilogram. Your latest rate.
This is the latest.
The latest.
So, as I said, we are working together. We are working together, and actually, the leak rate depends on many conditions. Probably what is interesting for you is what actually size of this crack. But really what we are doing, we are keeping pressure in per car lower, and the leak rate, how many kilograms we are losing every day, depend on how low pressure is in per car.
This is at full pressure.
And the pressure 0.1 kilogram per day is 100 gram of air per day is when we have full pressure in per car. Usually we keep it lower, and for a period of time we actually were thinking that if we just let all air from per car leak, we don't have any leak from station anymore. We need to repressurize per car if we need to have access to this volume on different reason. But actually last repair was very successful, and it looked like we significantly reduce leak rate.
Thank you. And that is going to wrap up today's news conference. Again, crew.
What a privilege having Krikalev there. That's badass, man. That guy's cool. He's a cool dude. I mean, can we not afford to send up a can of Flex Seal? That's what they did. Dude, they sealed it. They sealed the thing. 100 kilograms if they need to pressurize it to get into progress, but they can depress the vestibule. The SSVP, you can depress the dang thing. That's totally a thing. All right, dude. That's cool, man. Dude, okay, so you don't know why I'm geeking out a little bit. That was Sergei Krikalev. Sergei Krikalev has been a cosmonaut for, at this point for like 30 years. I mean, he's not a cosmonaut anymore. He runs the cosmonaut program for Roscosmos. So he's like a guy that runs the astronaut corps for us. That would be the equivalent. He's his first mission was when the Soviet Union was still around. His first mission to Mir in the late 80s. Well, actually late 80s, early 90s. The Soviet Union actually collapsed when he was on Mir. And he became the last Soviet citizen. And he had to emigrate to his own country when he came back down. He had to go through customs and stuff. Because where he launched from was the Soviet Union, and where he came back down was Russia. It's different. That guy's a legend. He's flown on the space shuttle. He's flown on Soyuz. He's been to the ISS. He helped build the ISS. He's been to Mir. He went to Mir with the shuttle program. He went to Mir with Soyuz capsules. Unbelievable, dude. Like spaceflight friggin' royalty right there. He's the last Soviet citizen, man. That's really cool. Yep, he was part of Expedition 1 with Bill Shepard. Yep, that's right. Yes, that was an astronaut name. Sergei's cool. He's the real deal. I've actually met him. I've talked to him face to face. That was 10 years ago. But, oh yeah, he's a good dude. Sergei's really cool. That's awesome, man. And for the people that are wondering, Ken Bowersox flew on the shuttle as well. I don't know if he ever flew with Sergei Krikalev. He may have. He flew on the shuttle multiple times. He did Hubble servicing missions. I think he was on the last one, if I'm remembering correctly. Wasn't he the first cosmonaut on the shuttle? That's correct. Sergei Krikalev was the first Russian to fly on the space shuttle. He flew on STS-88 in, what was that, 98? He flew the first ISS assembly mission on the shuttle, where they mated PMA-1 and Unity to Zarya, which is super cool. Like, dude, that guy's like a freaking legend, dude. It's very rare you come across astronauts and cosmonauts with that guy's track record. That's correct, Creeper, yep. Something like that, Kyron, yeah. But yeah, super cool. Crew 11 is going to launch tomorrow. I do believe the coverage is going to start a little bit earlier. I'm still mishearing this is shuttle launch control. Yep, this is shuttle launch control at T-minus 1 hour, 1 minute, and 30 seconds. Yeah, me too. Me too, man. Shuttle must have been a luxury ride compared to Soyuz. Pretty much, man. Pretty much. Hope he had his passport. No, I don't know if he did, David. He probably still remembers me. I highly doubt that. I know he remembers Sawyer, though, because he's in the same room as him. Yeah, that's right. He had his Soviet passport. Yeah, I remember now. Ship watching, what's up? All right, well, that's the Crew 11 press conference, guys. If you wanted to go through and see, like, what, Hey, Lumballs, what's up? The information that I did get is that Crew 11 is the last RTLS for LZ1. This is for Flame Trench, for the Crew 11 part. Sorry about Crew 11. This may be a hot take, but I think SLS needs a proper name like Saturn or Ares. No, I agree. I personally think it's a Delta. I call it Delta 5. It's a Delta rocket. It's got a Delta upper stage. Just saying. Hey, in the past, the only unifying nomenclature between different Delta rockets was the upper stage. The only thing that's similar between a Delta 3 and a Delta 4 is the DCSS. So if, per historical Delta naming conventions, if you take a Delta stage and you put it on a new rocket, you can name it. It can be the successor. Okay? And it's orange. That's right. Delta wasn't always orange. It was blue. That's another story, right? I personally think it's a Delta 5. I think it's a Delta 5 rocket. It has a Delta upper stage. Even the EUS. The EUS is derived from the ICPS design. So it's Delta. It's Delta. It's Delta rocket. Just saying. All right, so the other things that I got is that it's the 6th flight for Dragon. 6th flight for Dragon and Dragon Endeavor. Dude, where did the time go? That means Endeavor has flown more than once a year since its first flight. Unbelievable. I also heard some stuff about CRS-33 having a service module for station boosting. Did I hear that right? I mean, I did take some notes, but they weren't too good. So does that mean no more Falcon Heavy side booster landing on land, or can they squeeze? They're building new pads at 39A, Brendan. Don't worry about that. Let's put everything in the air. Believe me, I think they're trying, dude. A trunk full of thrusters. I'm gonna have to go check this. All this for Flame Trench. Yeah. I wrote it down. Here, I'll just show you the notes. I don't really, it doesn't really matter. So this is the notes for what I wanted. I put together a goggle docs here. So I have the X-37B stuff. I teed this stuff up with all the quantum inertial sensors and laser communications and stuff. And this is the stuff I'm gonna have to put on the screen. I have the Ares 1 launch failure is gonna be on there, but I haven't filled that out. I did put some show notes in for Starship, but I haven't really done them. They're not really complete. You know, it's good. It's fine. Yeah, I gotta do the Starship stuff, but it's cool. Gaggle Dax. You did not miss much testing today with Ship 37. Yeah. I learned today that apparently Alex hates technology and barely uses a word processor program. What? What? What does that mean, Fluffy? If there is time touching on the March Space Flight Center Blue working on Zero Boil Off, it sounds like an interesting topic. Does it, Creeper? Please tell us your opinion about it. Oh wait, no, don't do that. I know, man, I have it. Look, just because there's 3 things here doesn't, we have 4 topics, right? What we usually done in the past, right, is what we've usually done in the past is like had like a bunch of miscellaneous news as its own topic. So see you last. I had a talk with a guy in Launch Control Center at Johnson who's a family friend. This is not the first time Dragon has been used or attempted. What? What are you talking about, Graham? Used or attempted for what? You're typing right now, boosting the space station, right? That's what you're typing. Hit the enter key. Go ahead. We know. Station keeping. Using the Dragon for a reboost. There it is. All right, cool. Were you listening? Dude, the Dragon has additional thrusters in the trunk. It's got a service module attached to it. Did you hear that part? For all Graham kind. NSF Alex, during the tank watching Ship 37 stuff, hates tech. Jack has to help him at times, and so does KMR. But he's a writer for a space technology news organization. Okay. He uses notes to save and make scripts. I mean, I write stuff down, dudes, too. I do write stuff down. I don't mind. Is the next static fire for Ship 37 tomorrow at the same time? Where's the road closure stuff? Wasn't there a road closure thing on the website? Ah, it looks exactly the same. Got it. Yeah, they got us. They got it closed tomorrow. Interesting. County posted one as well. All right, cool. Let me transfer the rest of the links over here. Just adding more stuff to the document. Sign the document. All right, let me get the links here, and we'll transfer the rest of the Space News links over. The Crew 11 press conference did take up some, yeah. There. Gotta weasel that one in there. That one in there. There we go. Gotta weasel that one. A lot of ULA stuff. Okay, we got another Project Kuiper launch on the books. That's kind of cool. And then we got to talk about Ares 1. I think that's where we should start. All right. So, yesterday, let's go. Hey, paramedic fans. Wow, where the hell have you been? Hey, paramedic, you want to see something funny? Watch this. Watch this. So this is the Ares 1 rocket from Gilmore Space Technologies in Australia. It is the first commercial rocket to launch from Australia. And yeah, here, take a look. Here's the replay. I'm great, paramedic. How are you? Here, watch this. This is here. You know what? I'm gonna move over. I'm gonna move over there. I'm gonna move over here because just watch. So, that didn't work. Being busy as a one-armed paper hanger with scabies. Glad to see you still at it. I think that was supposed to go the other way. Yeah, no, it definitely didn't do what. I don't think that thing did what they thought was correct to do. So yeah, unfortunately, the first launch didn't go very well. It very, very much looks like they lost an engine. Now, I did some digging here about Ares 1. And I'll talk about it in a second. Either way, paramedic, man, it's good to see you, man. It's good to see you. It's been a while. I'm still here. I don't know if you ever saw, I got a garage now. I stream from my garage, from my shop. There's a live shot of my shop. I don't know if you ever saw that. The red truck does run. It runs and drives. I drove it this morning. Freb runs, just in case you were wondering. Anyway. So, that's how I'm doing. I'm doing pretty good. Anyway, I think it went further than we were discussing. It seems like it comes towards the camera. I think it cleared the fence. Yeah, I don't think it came down on the pad. I think that's just the camera angle. So, fellas, I did some digging here. So, this is the first stage is a hybrid rocket. So, what are hybrid rockets? Okay, what does that mean? If you leave the fence gate open, oh, I hope so. How's the rocket going to escape? What is a hybrid rocket? A hybrid rocket is a special type of solid rocket fuel that has, well, it has liquid oxidizer injected into a solid rocket booster. That's what it is. Hybrid rockets can carry you could use a bunch of different things for oxidizer for hybrid rockets. You can use a bunch of different things. You can use nitrous oxide. So nitrous, Virgin Galactic uses nitrous. They use nitrous injection on their Spaceship Two, right? That flies up, comes back down, right? You could use liquid oxygen if you really want to. If you have the solid fuel in the right proportions, right? Now, or you could use hydrogen peroxide, which is what that's what Gilmore is using in their rocket. Now, what's the benefit of a hybrid rocket engine? What does that mean? Like, why do this? Isn't this complicated? You get more performance out of it. I always tell people that liquid oxygen, or, well, any oxidizer, makes things blow up a lot better. It doesn't explode by itself, but it makes things explode really, really nicely. So spraying hydrogen peroxide on solid rocket fuel, if the solid rocket fuel is the right chemical and the right, whatever it is, I'll get more into that in a second, you can make a very energetic explosion. You could get way more performance out of an SRB. Now, it's like overclocking in Kerbal. Sure. Well, no way, really, that's amazing about the truck. Yep. Got it running in June of 2023. Drove it away for my wedding with Primo. It's a good time. Oh yeah, I don't know if you've seen that, paramedic. You've been gone a while. You've been gone a while. You didn't know that the truck got rebuilt. You probably didn't know that I got married and own a house now. Anyway, so hybrid rockets. So what is Gilmore doing? They're using hydrogen peroxide for their oxidizer. Fun fact. So what's hydrogen peroxide? You know what methane is. Methane is CH4. You know what hydrogen is. It's LH2, liquid hydrogen. So the LH2, 2 hydrogen, right? Methane is CH4, right? Liquid oxygen is O2, liquid O2, right? Hydrogen peroxide is H2O2. It's 2 hydrogens and 2 oxygens kind of combined together. You use it to disinfect cuts. Or you could use it as rocket fuel or rocket oxidizer. It's one of the only things that could be used as either one, interestingly enough. Now, they're using hydrogen peroxide. Now, why hydrogen peroxide? One, it's storable. You can, I don't know, if you got that bottle of hydrogen peroxide in your medicine cabinet that's been there for like 12 years, it still works. Very storable. Very storable. So it's a little bit easier to handle. And 2, whatever they're using for SRBs, whatever solid rocket fuel they're using, likes hydrogen peroxide. Now, so what does this look like here? This looks like the engines lose. So it's going up. She's going up here, right? And it looks like they got off the pad on 3 engines. Okay? One of the engines is coughing. It's sputtering, indicating a loss of chamber pressure. Now, so that looks right. Everything looks right here. And then they let the thing go. And right when they let it go, that engine immediately starts chugging. You can see it right there. What orbits can this do? Just 300 kilograms to low Earth orbit. The words of Charlie Garcia, The words of Charlie Garcia, friend of Joey B. Hybrids all have the complexity of a liquid engine with none of the benefits. I don't know why you do this unless you I don't know why you would use hybrids unless you had something. Now what is that thing that Gilmore has? Their SRBs are 3D printed. And from what I understand, I could be wrong about this, but I mean it could be that's the way I interpreted it. It sounds like their solid rocket booster and fuel is 3D printed. I don't know. Maybe somebody needs to go look up if PLA plus combines with hydrogen peroxide well. Right? So it's very clear that they had something went very wrong here. Now, something that I noticed about this rocket is that if you look, it is kind of constantly outgassing down at the bottom. I'm not sure if that's normal. Maybe that's the pad, like, see it's outgassing right there. Maybe that's the pad avoidance maneuver, if I had to guess, but they're on 3 engines right there. That engine, so it's making fire, right? But it's not burning well enough to yield a higher combustion chamber pressure to make a jet. All right, so with rockets, you have to be able to accelerate the gas, and the gas going out of the gas going through the throat and out the nozzle makes a jet of gas. It makes a very, very high velocity gas, right? That's what a jet is. If the combustion chamber pressure is not sufficient, you've made a really nice flamethrower, and that's basically what we see going on here. Now, I see that outgassing thing, and I originally said that maybe a LOX tank cracked or something, but there's no LOX tank in this design. Now, I'm inclined to say that outgassing is most likely the an attitude control system, because as far as I know, right, this is not that's not 4 nozzles, right, and 4 liquid fuel engines. There's 4 solid rocket boosters clustered in there and 1 LOX tank feeding 4. That's what's going on here, from what I understand. Now, clearly, one is not getting sufficient amounts of anything. It definitely has fuel in it because it's solid, but maybe something with the hydrogen peroxide plumbing went bad or whatever. It's basically 4 SRBs strutted together. So the RCS seems to be working okay. It looks like the RCS is just outgassing hydrogen peroxide, but I could be wrong. But it looks like you get to about here, and then if you look at the engine that's or the engine on the other side, right? Is that opposite? Yeah, it is. So it has 4 of them, right? 2 of them, those 2. So the one that's closest to us and the one that's furthest away. The other one does that same exact thing. And you lose thrust. You have 2 engines that are still doing well, but you have like 0.85 thrust at this point. 0.85 thrust to weight ratio. And the rocket immediately came crashing down and fell over. Now, interesting thing here. It splashed hydrogen peroxide everywhere. See those? Do you see those flames? Look at how strange those flames look. Very weird, right? They're kind of long and traily. Hydrogen peroxide. I mean, amongst other things. The hydrogen peroxide is what's going to make that really long orangey flame. Because hydrogen does that. Why no huge fireball? Cryonickel, if I had to guess, the hydrogen peroxide tank probably broke and it probably splashed out most of the fire. The fire looks to be only from the residual flame out of the boosters, but who knows? 10 out of 10, 10 bits launch. Paramedic vets, oh my god, dude, I'm so happy for you. I wish you a lifetime of love and happiness together. Thanks, man. Sorry, I didn't have my, the headset went out. Thank you. Thanks, Paramedic. I appreciate the bits, man. It's good to see you. Are you going to be sticking around or are you just popping in or what? What's up? Yo, what's up, man? We will boat mash you. What? Sorry. I love how you can see the grass catch fire when the HTTP cloud touches it. Yeah. 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 but it definitely looks like it put it out. Hydrogen peroxide contamination, from what I understand, is not great. It's not great. It's not great for the ground. 22 cars in a boat. How did you wreck a boat? So that's what's going on with Gilmore. Unfortunately, she didn't do it. Now, check this out. We did get some stills here. And you can clearly see in this picture right here, take a look. You got three. Three are working very well. That looks real nice. That one, not so much. Complete lack of combustion chamber pressure. Now, whatever this is, it's a compounding problem because the second engine did the same thing, and that was definitely uncommanded. This one was about to go. Like right after this picture was taken, this one croaked. So something is weird. If I had to guess, guys, because, I mean, and keep in mind, I don't know hybrid motors too well. If I had to guess, this is probably something with the H2O2 feeds. If I had to guess, if it was one engine, hard to say. Second motor, same exact behavior a couple seconds later. You may have had a hydrogen peroxide leak or something. Is that Rocket Happy's long-lost brother? Sad? Yeah. Yeah, see, that one is not maintaining chamber pressure. You can see you have drastic overexpansion here. Like, drastic. See how the flames coming out don't look like this nice hourglass? That is what you want. That is not what you want. Hey, Nazalik, what's going on? So, unfortunately, it didn't go very well. But here's the thing. Once again, dudes, it's the first launch. I said this probably 30 seconds before they launched it. They've scrubbed this so many dang times. You know, they scrubbed it here, scrubbed it there. They, they're fairing deployed and stuff without, like, when they tried to launch like a couple months ago. You know, they kept having abort after abort after abort, and I said something like, your flight rationale is way too conservative here. It's the first launch. Just get off the pad. Just get off the pad. That's it. That's all you got to do. That's great for a first launch for a commercial company. Everybody hopes for success. But you really have to know what you're doing if you want to get it right on the first try. You really have to know what you're doing. And Gilmore is an Australian startup, totally privately funded out of nowhere. Roger Mojo, 27-month resub. Thank you. So, at the end of the day, you just got to send it, dude. You just got to send it. Whatever happens, happens. And unfortunately, what happened is not what they wanted. But that happens. It's fine. It got away. Your GSE is okay. The pad's all right. Yes, it blew up. I'll bet you the people were looking at this in wherever their flight control is looked at that and they're like, oh, crap. We know exactly what that is. Bet you they figured it out already. As long as it didn't destroy the pad, you're good. Sequencing an ignition and separation from a launch pad is a lot more difficult than you might think. It's not just hit the space bar like in KSP, right? According to Scott Manley, it seems that Aris has a pump for the for the hydrogen peroxide? Huh. Really? That's unfortunate, man. But hey, what are you going to do? It got away from the pad. You're fine. What an interesting rocket this is. Hydrogen peroxide, pump fed. I mean, yeah, I suppose you couldn't do pressure fed hydrogen peroxide. I'm not sure that would end well. Right? I assumed it was pressure fed. That makes more sense though. If it's a pump though, you may have, if the pump may not have been sufficient, you know? And that would go back to what I was saying with feed lines, Black. Feed lines are difficult to figure out with rocket engines. I mean, you remember when SpaceX fished out the booster the other day? See all those feed lines? They didn't just make all those pipes and were like, yeah, I hope it's good. No, it's a very complicated thing getting commodities through a rocket. All right, so what do we got here? Ares 1 test flight. Here's an update from them this morning. Today, Ares became the first Australian-made orbital launch vehicle to lift off from Australian soil, achieving around 14 seconds of flight. For a maiden test flight, this is a strong result in a major step forward for Australia's sovereign space capability. Smooth operations through terminal count and T0, successful auto sequence and ignition of all 4 engines, 23 seconds of engine burn time, 14 seconds of flight, successful integrated operation between rocket and ground systems, liftoff from the Bowen spaceport, clearing the tower, flight software GNC performing as expected, extensive flight data collected, safe execution of launch and range operations. From early indications, launch site infrastructure appears to be intact. But most importantly, the team is safe and energized for Flight 2. Only 6 nations launch to orbit regularly, and just a handful are working to join them. Today brings Australia closer to that club. Huge congratulations to our tireless team, and thank you for all the support. On to Mission 2. There you go. That's it. That's the right mentality to have. Put the second one on the pad. The pad's fine. Put the other one on the pad. Fix whatever was wrong and go. Because I'll bet you it's very apparent to them, to the people that have telemetry in front of them, what went wrong. It's really easy to see it when it blows up in your face. It's like, oh, well, there's your problem, right? So put the next one out and go. I'll say what I always say anytime somebody doesn't get to orbit on the first try. It's like the jump program in the Matrix. Everybody fails the first jump. Morpheus is fighting Neo. Show me. No? Alright, cool. But anyway, that's awesome for Gilmore. That's really cool for Australia. Pretty psyched for him. That's really, really neat. He's beginning to believe. Grab Shark. So what did you think of her? The woman in the red dress. She doesn't talk much, but you'd like. Arrange a much more personal relationship. Pay no attention to these hypocrites, Grab Shark. To deny our own instincts is to deny the very thing that makes us human. Can you do a static fire on this type of engines? LM, I'm not too particularly familiar with Gilmore's testing regime, but I don't think they could do it with that one because it's solid rockets, right? But they have done it before. Wasn't it a miracle for IFT1 to get off the pad? Yeah, and it did, and it almost got to stage separation, which is just all right. Hang on 1 second. I'm adding the show notes for the Flame Trench. Because unlike Alex, I know how to use a word processor. I'm just kidding. Alex is my boy. I'm trying to do the text. Took the text format. Okay. The Hearts of Iron VOD got demonetized? How? What? How? It's got to be when Flight of the Valkyries plays. Okay. Anyway, so yeah, I'm gonna read more about the Ares 1 rocket, dudes. Because unhistorical, yeah, right. Yeah, right. Yeah, so one of the songs in Hearts of Iron gets muted. Sure sounds like YouTube isn't worth the hassle. Muttered, you know what's crazy? Despite all the constant demonetization, I'm pulling in like $250 a month from YouTube. An ad rev for a stream gets about 100 people. Believe that? Isn't that nuts? The ad rev's worth it, man. If you get one of these videos that gets a good amount of views, or one of these VODs gets a good amount of views, you're gonna make some change. 250K, 250 bucks. $250, not 250,000. If I had 250,000, you think I'd be sitting here playing Kerbal? I don't know, Black Eagle. We might have to just mute the music, which kind of sucks. Yeah, and if we do YouTube memberships, it's going to get more. I need to still do that. That's on me. So yeah, the ad rev is pretty damn worth it. Most videos don't get demonetized, but I'm bummed that Hearts did. Hearts mutes Twitch for Hearts gets muted on Twitch sometimes too, which tells me one of the songs is too close to a real song, so it's probably Flight of the Valkyries if I had to guess, or Bella Ciao. Bella Ciao mutes it, which sucks because I like that song. I hope you still keep playing if you made 250K. Denny, if I've always said that if the stream ever comes into like a crazy amount of money like that, I probably won't play KSP as much because we'll be building real rockets. Is that fair? Is that a fair trade-off? And I'm not talking like high-powered rocketry either. I'm talking like rockets. Valid, fair, and fixing more cars? Yes. Flight of the Valkyries would be public as classical. Yeah, Foz, in a world that, with morals, yeah, absolutely. But no, unfortunately, individual recordings of Flight of the Valkyries are copywritten. Individual recordings. So, like, if it's Flight of the Valkyries that was played by the Boston Symphony Orchestra in 1997 or something, that version is copywritten, even though the song is public domain, because the music industry is... You know what? I was going to say something. I'm sure you can think about where that's going, but I won't say nothing. Okay, John. Yeah, that's how that works. Just because the song is in public domain doesn't mean you have rights to restream every single version of it in perpetuity, because let's just split hairs because you need your money, right? Like, it is what it is, dude. I don't want to talk about it. I can dispute it and say it's game music, and then it'll go manual review. So, whatever. Now, don't get me wrong, guys. I don't. The flip side of that is that I think you should. I mean, that's just. I do believe in intellectual property. Like, my one gripe with content creation, guys, is that, and this is, like, my one gripe. Like, I do believe in intellectual property. Like, it's your music. You wrote it. Or, I mean, I don't know about Ride of the Valkyries or something, right? But if it's your own song, it's yours. It's yours. You should get paid for your work. I don't ever have a problem with that. That's fine. What I do have a problem with is that, like, okay, say I wanted to play Led Zeppelin on my stream. There's no chance. There's no chance. I can't afford that. So, you know, like, if there was an easier way to do it, there was an easier way to get rights to songs, I would be pretty happy. But once again, that's down to individual songs, right? Not all songs have a blanket copyright. Every one is an individual piece of work, you know? So, like, I would really, like, where my critique of this whole thing is that it's so easy to get something muted, and the burden of proof is on me and not on the person making the claim, which is stupid. You know, that's just, that opens the door for fraudulent claims, right? I mean, this isn't anything that anybody doesn't know, but hey, I tell you, preach. It's just, if we had a way to, like, okay, so, like, here's the thing, and here's what I was getting to. That all sucks, but dude, even if we did, even if I hit the lottery and got the rights to play Led Zeppelin, and I played Led Zeppelin on stream, I guarantee you every single video would get muted. Every single video. Even if I went to Twitch and said, I got the rights to this song to stream it in perpetuity on a stream, every single one would get claimed. Every single one. That's the problem. That's what I have a problem with. Even if I could afford it. Even if we could afford listening to, like, Van Halen on stream, or Led Zeppelin, or the Beatles or something. Or pick your favorite music artist. If we have to jump through all these hoops, I'd have to jump through all these hoops to get the licensing for the music, etc., to listen to whatever I want, etc., If I jump through that whole legal process, I'm still dealing with the demonetization problems. You'd still deal with it. You still have to deal with it. It's so annoying. That's ridiculous. Yep, that's happening to a YouTuber who posts popular top 10s and has taken pains to go get the rights. That's right. So yeah, AI music it is. So, like, that's how bad it is. I'm in a position, guys, where I want to pay people for their work. I would love to do that. I would love to listen to this music on stream. I'd love to listen to, you know, like Alice in Chains. I'd love to listen to them on stream. I'd love to do that. I will pay to do that. But the system is so bad that you can't. Like, even if I got the rights to the song, it's not even worth it. I mean, you'd be better off learning to play the damn guitar. In which case, if something sounds even remotely like something else, you're going to get flagged anyway. Like, this is the plight that we deal with. I wonder if YouTube has fake accounts that claim videos to steal revenue. It literally happens every video. Yes, absolutely. I have to. It's part of my day. Part of my day disputing it. People just claim stuff and hope that it sticks. So, once again, guys, I don't have a problem with intellectual property. I don't have a problem with how the music industry does things. I really don't. You should get paid for your work. Now, doing covers of songs that are in the public domain, that's kind of ridiculous, but whatever. My problem is just with content creation. There is no avenue. There's no recourse. There's no avenue. If I spend thousands of dollars to play a song once on stream, there is still no guarantee that I will ever get that money back. It's not to the point where it's not even worth it. So I just started playing AI music because AI doesn't flag nothing. It doesn't flag nothing because it can't, because it's AI. And I know people don't like that. I get it. But in the future, Bluetooth speakers will scan for audiences. And if more than the individual is detected, they will smell mute to protect IP. Yeah, yeah. It's ridiculous. Yeah. But anyway. Yeah, it sucks. Yeah, I mean, the Hearts of Iron thing got muted. Here, let me see what's disputing it. Hold on. I mean, it's not like that playthrough. We pulled it out of our tail and actually did really well. Shutterstock Music is claiming a song called Skyscrapers by Kevin Mason. Hexacorp. Yep. That is a claim troll. Together We Fly by Kevin Mason. Shutterstock Music. Yeah, this is... Oh, there's 5 claims. Yep, Shutterstock Music. Desert Storm by Cody Martin. Sounds... Oh, this is awesome. Desert Storm, Soundstripe Incorporated, audio not monetizing. Someone is claiming the wind noise that Hearts of Iron makes when you pause the game. The wind noise. The wind noise. Because it sounds like a song that has wind playing in it. Oh, yeah. Dude, you think I'm kidding? Look. See? See that? That's bullshit. That's what that is. That's who claims a damn sound effect? What do you have? It's like when those guys tried to claim reaction videos as intellectual property. Shut up. Get out of here. Go home. Bro, the rain noise in RimWorld is auto muted on Twitch. All your VODs get hit. Why do we do this, Etal? Why the frick do we do this, dude? Why do we do this? Why do we do this? Like, what are we doing? So, I have to go fix that mess. You know, that's good. I ask that every day. We do this because we love it. Let's not kid ourselves. But also... Anyway. Etal, you ever seen Home Alone? You know Joe Pesci's character? At least his Zoidberg impression won't get flagged. That's right. That's right. Wind sound. I want to punch that person in Minecraft. Like, out of principle. You know what I mean? In Minecraft. Ooh. 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 You know, like, see, that won't get claimed. Because I can do an impression. And it's transformative, jackass! Anyway, more space news. Let's go. More space news. Let's go. Ooh. I'll give you a wind sound. What was that, chat? Nothing. See you tomorrow in class, Miss Vaughn. You blow it! This is coming from Northrop Grumman. Special delivery. Thales Alenia Pressurized Cargo Module, or PCM for short, for the Northrop Grumman 23 resupply mission has arrived at Kennedy. Is that the space station processing facility? That's what it looks like. Pretty cool. Pretty cool. Don't drop it. Yes, precisely. Don't drop it. Notice anything different? This is our stretched Cygnus, designed to carry an additional 1,300 kilograms of cargo to the space station. We call it Bigness. Bigness. Oh God, they're gonna drop it. Don't drop it. Don't drop that. Don't drop that stuff. Don't drop it. Pray to God you don't drop that stuff. Frickin' right. Actually, hold on one second. Hold on. Hold up. Yo, an MPLM. There's another MPLM sitting back there. Let's go. Hey, that's all 3 of them accounted for. Axiom has 1. Lockheed has 1. And NASA still wait, no. NASA has 2. What the hell is that? That is a multi-purpose logistics module. That's left over from the shuttle program. And there's 1 on station, but there were only 3 made. Mystery MPLM. Nice. Cool. So this is inside the space station processing facility, which is pretty sweet. Might be a fitting analog. That's my guess, dude. Cool. Don't drop it. All right. Actually, speaking of that, speaking of things that are made inside of the space station processing facility, special delivery. First pieces of flight hardware for Artemis 3 are now in the VAB, the SLS bow tail and engine section. This marks the first time the 2 SLS rockets are being assembled simultaneously in the VAB. So, like I said, they installed all the components in here that they needed to install in a clean room environment. They took the bow tail off, shipped it, finished working on this, and shipped that. They're going to install the 4 engines in the Futuramic jig inside of the VAB, which is pretty cool. What would be a launch vehicle for Cygnus XL? Is there an Atlas? I do believe that's... Ooh, video. Nice. Ooh, let me check the magazine. Hang on 1 second. Do you sell hubcaps for 72 Pinto hatchback? One second, I'm adding it to the Flame Trench notes. Artemis 3, yes, is in the VAB. Come on, give me the video. Give me the video. Give me the case. Give me the case. Give me the video, child. Give me the case. Now away, you psycho. What? The case, child. Give me the case. Are they going to claim this wind sound? They might. Hey, fellas, they moved the MPS. So this thing is going to get installed in a jig. The jig is in High Bay 2, which is right, it's around the corner right here. There's a transfer thing right there. It's going to get put into a jig in High Bay 2 that was made by Futuramic in Michigan. Futuramic makes assembly line tooling for the automotive industry. But they made the jig for stacking this. They're going to use High Bay 2 to build or do final assembly on core stages before they stack them on the launcher. Having the MPS in there, guys, tells me that the Artemis 3 stack is going to come together pretty damn quick. Yeah, Dino, Futuramic. They make, you know, like all the platforms and overhead catwalks and stuff for like that you see in like on the lines. Yeah, they make stuff like that. Yeah, Futuramic's cool. So saying the jig is up. Well, no, the jig is down. It's in the high bay at the bottom. So, guys, I originally said, like, you know, they just have the bow tail section in there. Who cares? Like, that's just one piece of the entire SLS. But no, moving the MPS and putting the you know, we'll see in the coming weeks them pick this up with one of the big cranes up there and stack it in the Futuramic jig. And when they do that, that's actually stacking. Yo, they have 2 SLS cores inside of the VAB. Well, one is being assembled, but that's cool. That shows processing flow for 2 rockets at once, which is pretty good. Artemis 2 is down in high bay 3. The VAB has 4 high bays in it. So there's high bay 1 over here, which is abandoned. High bay 2 is where they do core stage stacking. High bay 3 is where they do final stacking. And high bay 4 is where they store SRBs. Yeah, high bay 1's been abandoned for a while. Since July of 2011. It's still in shuttle configuration for stacking because... Oh, another cool thing. See those platforms right there? Those are platforms that actually fold down. Speaking of abandoned, you can actually see one in the folded position over there. You know what that is? That's the S4B. That's an S4B processing cell. For Saturn V third stages. Yeah, there's 4 of them in the VAB. Yeah. Yeah, there's still... Yeah, those are still there. You know. I'm not sure why. Some platform work is coming up. Can't say what and when, but soon. Yeah, those are S4B processing cells. So if you guys have ever looked at NASA's VAB, right, from the outside, you'll notice the VAB has kind of a thing on the side, this, right here. That's third stage processing. Third stage processing and payload integration. There's 4 cells right there. That's what this thing coming off the side of the VAB is. Yeah, for stacking upper stages. You never know when you might need it. So we have 4 processing cells that are not being used from the Saturn V, and 1 high bay that's not being used from the shuttle program. Do you guys understand why I go on rants from time to time where I'm like, please just use the VAB? Just use it. I don't care if you have a dance party on the stupid processing cells. Just use the damn thing. Use it. Look, it's got a dance floor. Just put a fence around the center so you don't fall in. Anyway, the engine section's really cool. I like the commag that's being used to transport it. That's actually really neat. Why would the government use something they already paid for? Don't say it! Look, see? There they are. 1, 2, 3, and 4. You know why there's 4 processing places for S4Bs? Because there's 4 high bays, because there should be 4 Saturn V's frickin' being made all at the same time in the VAB, because that's the capacity that they frickin' made it for. Mother. Remember your pressure points. Remember your pressure points. Woosah! "23 cars. And a boat. How did you wreck a boat?" It's scrub, knick-knack. Hey, at least, they're using it for something. I'll take it. Only 2 launch pads, Chip. Yeah, because you're not going to put 4 Saturn V's out at the same time. The most you're going to need is 2 at the same time. That's why they only built 2 pads. That and if a Saturn V blew up on one, you'd be having a bad day. You might need another pad soon. Can I cross this rant with the Fifth Element? I am a bit disappointed. If it's one thing I do not like to be, it is to be disappointed. Anyway, let's see what else is in this B-roll. You thinking what I'm thinking? Yes, make the Saturn V. There's the Futuramic jig. Make more Saturn V's. I like that idea. Let's do it. That's the jig over there. Okay, positive note. So this stand right here, the processing stand for the MPS, only now, after, doing a ton of welding and fabrication and lining stuff up with jigs and everything, only now do I actually realize and appreciate how difficult it was to make something like that perfectly square. All the support equipment, dude, that must have taken forever to make that damn thing. Because it's got to be perfect. That's not that you can't make a box, right, really quick. I mean, unless you're Boeing. Like, anybody can make a stand. That stand has to be perfect because you do not want the MPS to move around. You don't want it to shift. You don't want to go to set it down and have it, like, be leaning to one side or have it, get all out of whack. Right? That's pretty damn impressive, the amount of work that went into making like something like that. Or even the Commag next to it. That's a one-off vehicle, so somebody custom made that thing. It's like it's hot rodded SPMT, which nice. So that right there, hold on one second. So one of the engines goes right there, but it doesn't, I forget if it mounts directly to it. I don't think it does. You look at the green one thing. Yeah. Mm-hmm. So that is not the direct outside, but see right here, that's an SRB mount right there. Those two. So an SRB would be right here, and an engine. That's not the mount. The mount's actually up in there because the turbine machinery is riding inside of the MPS. So the nozzle is down here somewhere, right? What that's for is the outside piece. A lot of people don't know that the SLS MPS actually flares out around the engines because fittings for these next to each other is complicated. Did the shuttle have a similar kind of stand for its propulsion system jig? When it was originally made, T-Man, yeah, but the shuttle didn't need something like this because the shuttle MPS did not need to be integrated every time. The shuttle did, though. The closest thing that comes to something like that would be like NASA shuttle OPF interior. Sure, if we type that, orbiter processing facility interior, you'll see the jigs that they use to reinstall the engines. Actually, this is pre-engine install on the orbiter. Did Boeing make that cylinder as well? Yes, they did. Now, guys, I'll be 100% honest with you. And people aren't going to like this. People aren't going to like this answer. I think it is entirely okay that that is behind schedule. That is an extremely complicated thing. To the point where you probably should be reusing it, hint, hint, nudge, nudge, considering the vehicle that it borrows parts from. Right. Oh, they took the MLP out of the high bay, and they're staging scaffolding in there. That's nice. I very much understand why this took so long to make, and I can almost excuse it, because that's basically the back of a space shuttle that's shaped like an external tank. That's what that is. It's an MPS. It's derived from the shuttle's MPS. The shuttle's MPS is more triangular shaped because the back of the orbiter, that's a cylinder. It's the same thing with another engine. It's quite actually the same thing. So that other picture that I just showed you from inside of the processing bay right here, this triangular piece on the back of the orbiter, that's the shuttle's MPS, right? SLS is this. SLS is that same exact thing with 4 engines in a cylindric shape. So I can almost excuse that. The cylinder with the EUS is kind of ridiculous, or the box with the EUS is kind of ridiculous, but that's still cool. It's still cool that the Artemis program is making progress. I think that's really neat. S4B processing stands just sitting there doing nothing. And that's the bow tail segment for it. You could see that they're blowing positive pressure in there to keep contamination out, because the VAB is not a clean room. It's a contaminated environment technically. Because, dude, I wouldn't even want to know what the electrical bill would be for air conditioning something like this. All right, Wartos. See you, buddy. I don't understand if it's 2 to 3 years. It's like 6 years plus delayed, and it's not even that revolutionary. Dude, getting 4 shuttle engines to work together like that is, I would disagree. And getting them to jive with 2 SRBs when they're super close like that, I would argue is a very complicated thing. Now, said, I would agree with you if the Saturn V was still flying. If we were still flying the Saturn V and somebody came along with this thing, I'd be like, what the hell are you doing? Why would you do this? This thing is a piece of junk. But because we don't have another one, you know, personally, I think having a conventional means for like conducting a space program, so like a super heavy launch vehicle, not launching every hour, launching like maybe 4 times a year to the moon to conduct research, to do sustainable presence on the moon, etc., etc. Basically, NASA rockets, I think, is okay to have with the commercial market also coexisting in its own thing. I like both. And since NASA doesn't have anything like this, I don't necessarily mind it, dude, to be honest with you. I know people are going to hate me for that. That's fair. Seriously, it's taken way too long. I don't have a problem with stuff taking time with spaceflight. What I do have a problem with is companies rewarding themselves for being incompetent. Boeing was getting contractual milestone payouts from NASA for not meeting deadlines. They're like, oh, did you do this? They're like, no, we didn't meet the deadline. Well, can you pay us anyway? Yeah, all right, fine. That's kind of on NASA too, though, but whatever. 5 Saturn V. Space Pope, the more I think about it, the more I think in this day and age that it wouldn't be as difficult as we think it is. Now, don't get me wrong. Building a super heavy launch vehicle is an extremely difficult endeavor, and I'm not saying I could do it or oversee it or do anything like that. I'm thinking as long as you have a good amount of venture capital, it could be done. It really could be done. Like, let me put it to you like this. If SpaceX wanted to build the Saturn V right now, they could do it. And I'm sure they could get it done. I actually think they could get it done on a pretty damn expedient timeline. Like, if, say, Elon wanted a pet peeve project, right? That's all, you know, supplementary to Starship or something, right? I'm pretty sure they could get it done in about maybe 5 to 10 years. Like, it's totally doable. Yeah, but that's never going to happen. Elon would never make an expendable rocket. But I think once again, I think a Saturn V with modern manufacturing methods, all systems like you said, I don't think that is far-fetched, because a lot of the manufacturing. Okay, give me 1 second. Sorry, my mind jumped like 3 chapters in my head. There's this book, and you should buy it. It's awesome. It's called Rocket Ranch. It's the nuts and bolts of the Apollo program. This tells you all, not necessarily stuff about the rocket, but there's stuff about like all the control systems and all the launch GSC, how that all goes together and how they came up with it. This is like one of my all-time favorite books, right? Why would I read it when I have you? Nice. In Rocket Ranch, they talk about all the manufacturing challenges that they had with the Saturn V, like welding, for instance, like welding the thing together. It was all hand welded together. The Saturn V is handmade. Think about that for a second. It's handmade. Like, it was made using machine tools, but all those machine tools were operated by hand. Freaking thing's handmade. That's crazy. So another thing is, like, the Saturn V is using hand-welded internal stringers. Guys, with modern billet manufacturing, we could easily make something like that. That's not, I mean, don't get me wrong, it's building a rocket. That's complicated, but that's not like a lot of the manufacturing. The point that I'm trying to make is that a lot of the manufacturing methods from the Saturn V, like a lot of the big things that were a challenge that made it so expensive and so complicated, are not expensive and complicated anymore. Partially because of the strides the Apollo program made. But you think about that. The Saturn V is handmade. Handmade. People welded that together, which is just, they TIG welded the damn thing together, which is, it's pretty damn impressive, dude, for what it is. If you have a picture of them putting this stuff together, like, look at this damn thing. Freaking handmade. No EJ affiliated link? Nah, no. Just buy it, dude. I don't do stuff like that. Like, dude, look at it. They made it on jigs. They made barrel segments. I mean, rockets are still made like this, but dude, you could make this so much better today. Like, even an S4B, you could with the right jigs, you could tee this up real quick. You could mass produce these damn things. My case in point, once again, is like Falcon 9. You could mass produce those, no problem. Your long lead would be propulsion. The tankage and stuff would not be that difficult. Which is, once again, I know. Some dumbass Twitch streamers sitting here talking about how rockets are so easy because you played so much Kerbal Space Program. Right? No, I get it. I know the manufacturing challenges. I understand. What I'm saying is the stuff that made the Saturn V hard to manufacture is not going to make it hard to manufacture today. Getting the money to do it is going to be the hard part. No CLPVs in the Saturn V's design, Jim. Yeah. So yeah, you could save tons of mass too with stir welding. So Jim, like you said, with stir welding instead of regular welding, you stir weld the Saturn V together, I guarantee you probably save a couple £1,000 worth of welding bead. Much, much, much lighter doing a stir weld. Boeing couldn't modify a shuttle tank to SLS in 8 years. Sad. See, that tells me that you don't know too much about the core stage and what it is. It looks like an external tank. It's not an external tank. It's manufactured completely different. It's the same thing that I'm talking about. The external tank had hand-welded stringers in it, and it only really towards the end of the shuttle program switched to friction stir-welded design. Well, no, that's not entirely true. It was using stir welding, but it still had it still had stringers in it. With the SLS core stage, Boeing switched to a isogrid, or an orthogrid friction stir-welded barrel segment design, and that took a lot of time to make, because they had to make the new manufacturing equipment for it too. Which kind of defeats the purpose of using off-the-shelf technology like the shuttle motors. That kind of defeats the purpose, because the whole idea of a shuttle-derived launch vehicle is that you're using the tooling from the shuttle program But there was a little bit of a snafu. They figured out that you can't do that with a rocket that doesn't have a shuttle mounted on the side. You can get away with hand welded or like not billet stringers inside of the external tank because the shuttle's on the side. And you have your engines pushing up from the bottom, right? And you have a payload on the top. You can't do that. You can't make it like the external tank. And if you did, you wouldn't be able to use 5-segment boosters either. That's why direct existed. Remember, you guys know the direct rocket, which is an external tank with a payload fairing on the top. That's exactly what that is. You wanted SLS, you wanted to strive for the 5-segment boosters. I mean, to be honest with you, we should have done direct, which was much simpler because it used the same tooling as the shuttle program. SLS didn't. Part of the reason why it took so long is because they invented a new assembly line for SLS core stages. The more you know. Bing, bong, bong. That actually defeats the entire purpose of using shuttle components. But whatever. Yeah, L8, we could do it, man. We could do it. Like, the more I think about it, man, you could make Saturn V. Like, the unknown unknowns would lie in the manufacturing knowledge that was lost in that time. Because everything was hand machined, nothing was really written down. It was just, oh, Jim can hand machine it. He's the guy that builds the, turbo pump assembly. He can machine that just fine. Jim really didn't write a process for it because he's a skilled tradesman. He doesn't. Electricians don't write out a process for wiring a damn house, right? You just do it, right? Like, okay, there needs to be an outlet there. There needs to be an outlet there. Okay, I'm going to wire this. That's not really how that works. I mean, don't get me wrong. I understand that tradesmen read blueprints and stuff. I get it. But the actual process for putting the stupid thing together, that's what was lost. So we'd be playing into a bunch of unknown unknowns in that regard. So like, let me put it to you like this. We'd go to build an F1 engine. We try to get it built and then it would probably blow up a lot. But hey, whatever. It's fine. You learn. I do love how the Saturn V used lasers to figure out how it was oriented.
Taco Bell's 5-7.
Oh boy, here's some ads that I didn't want. Guess what? That'll probably get claimed, by the way. Somebody's probably going to claim the ad. Thanks, Hellfish. Appreciate it. Guys, just don't link YouTube videos. Just don't do that. Just stop. It's too much of a pain in the butt with stuff getting claimed. Just don't do that. I know the Saturn V had used the laser pointers on the pad so they could configure its inertial guidance system, which is pretty cool. But yeah. Ad blocker, my dude. Yeah, see, there's this thing about ad blocker. There's this thing about it that, every once in a while it doesn't update quick enough and plays ads for you. It's this thing. Why is it that when I ask people to do something, they say no? You basically, in so short words, say no. Don't do that. You're wrong. No. I'm pretty sure I asked you not to do that. Like I don't know how that could have been misconstrued, but it's okay. It's fine. So can I go invade Carthage as Rome? What? What? What was I talking about? Whatever. Doesn't matter. Yeah, Artemis MPS is in the VAB. Check this out. Tori Bruno has some updates to Slick 3. This is Vandenberg's. This is the Vulcan rocket's Vandenberg launch site. It originally was for Atlas V, but they've been upgrading it for Vulcan, which is pretty cool. They added new tanks and stuff. Centaur locks right there. Booster, liquid oxygen. New fixed launch platform. Created an umbilical tower. There's pneumatics, hydrogen. Liquefied natural gas. That's actually super cool, man. There's your heat exchangers over there. Or vaporizers, excuse me. No, Colonel Sanders, you're wrong. Mama's right. Cool. So this is designed to launch Vulcan VC6, which is, yeah, that's pretty neat. Here's another couple of shots from Tori Bruno. Frickin' Vandenberg, man. Look at that place. That part of California is just... It's Amalfi Coast-esque. Let me say it like that. Just look at that water. Look how blue it is. Google changed the API, so ad blocking is a lot harder in Chrome. Other Chromium browsers and Firefox aren't affected. Yeah, I see that. See that light through. Yeah, believe me, I noticed. Oh, also, just while it's on my mind, that ad was for Taco Bell. Don't go to Taco Bell. Taco Bell sucks. All right? It sucks. It literally, I could crap food into a wrapper and probably make something more edible. Go to Chipotle or something. Seriously. Don't ever go to Taco Bell ever again. Okay? Cool. Glad we're on the same page. Never been to a Taco Bell. Good. Keep it that way. No, EJ, but it means fast food. No, it's literally crap. It's literally terrible. Thy time in Texas hath served thee well. It's crap. It is like F tier in terms of fast food. F tier. It's awful. There's 1,000 other fast food places that have food that's just as bad as and unhealthy for you that doesn't taste like dog crap. You had it once. Primo, it's awful. It's awful. It's awful. It's awful. Just, it's awful. Sorry, that pisses me off. It pisses me off. It's always ads. Always. Someone has to sell you something all the goddamn time. It infuriates me. Also, that SLS thing, Saturn V thing we're talking about kind of pissed me off too. But hey, whatever. Somebody needs to sell you something. It's all the time on your phone, text messages, YouTube, TV, everywhere. It's so tiresome. I can't stand it. I hate it so much. I'd rather not make money off ads. I'm not even kidding. You eat dog crap? No, I heard it from Shooter McGavin. He eats pieces of crap for breakfast. Weren't expecting that. Taco Bell is actually under less FDA restrictions than dog food. Yep. Cool. So this is Vulcan Centaur's new pad. It looks like they still got a little ways to go with the umbilicals. The umbilicals aren't there. Soon though. Now, if you're wondering, Slick 3 was an Atlas V pad, and it uses a completely different design than the Atlas V pad at the Cape. It's totally different. It uses a mobile service tower that stacks the rocket directly onto the pad, rather than a vehicle integration facility that has a mobile launcher that gets towed to the pad. The pads are just fixed in this design. Slick 3 at one point was a twin pad. Oh, hold up. Slick 3 was a twin pad launch complex at one point. Boop. Man, that thing's really going. Sounded pretty good, man. Sound pretty good to me. Nice nominal honk and shutdown. I'm in a better mood now. That's pretty awesome. But yeah, you could see that Slick 3 was a twin Atlas launch pad. You could see the other pad was over there, but they never made a second pad. It's just using one. Just like SpaceX at Slick 4 only has one pad for Falcon 9. That's because Slick 4 West is their landing pad for reusing rockets. Just saying. Dude, you could still see all the block stuff there from, and the trench from the pad that was there. I do believe the last thing that launched from Slick 3 West was Atlas, I think. Slick 3 West, demolished. First launch, Atlas Agena. Last launch, March 24th, 1995, an Atlas EF. Yeah. Atlas EF is a derivative of Atlas Centaur. Cool. Actually, was it an Atlas? It's just a straight Atlas EF USA 109. I don't know what that just might be. I don't know what upper stage that has. Atlas EF was flying into the 90s. Yeah, man. Titan's last. Okay. You want to hear something crazy? Titan 2. Not 3. Not 3C. Not 4. Titan 2's last launch was in 2005. Seriously. Had to exhaust the missile supply somehow. When they stopped using Titan 2 missiles as a nuclear retaliatory strike weapon, they decommissioned them in the 80s. They had a bunch of extra Titans. So they used them all up. They were gone by 2005. Was it Raptor 3? Not sure. Yeah, the last Titan 2 launch was in 2005 from Slick 4. Falcon 9's pad. Not kidding. Last Atlas 5 that went out of Vandenberg was JPSS-2 and Lofted. That was a great mission, man. I missed that one. I fell asleep. Starbase Live, Starbase Live. Seriously, look. Yeah. So the orbital launch vehicle variant of the Titan II, what is it? LGM-25? LGM-25 was the Titan 23G. Those are all ex-Titan II ICBMs. And there's one launching. 23G, NOA-15 in 1998. Look. It was 2003, not 2005. I was wrong. But there it is. Look at that. Slick 3. Yeah, no. Is that Slick 3? No, that's Slick 4. Too close to, yeah, that's Slick 4. That's where SpaceX's landing pad is. That's Slick 4, that's Slick 4 West right there. Never knew that they had liquid ICBMs. So Skeleton and Atlas. Okay. I see a little bit of an ICBM rabbit hole. The earliest ICBMs that the United States made were, so, okay, obviously the V2 missile that we lifted from the Germans, Hearts of Iron style, right? And we renamed it Bumper. And the earliest ones were, yeah, they were called Bumper, right? But see, you got to remember the V2 is an IRBM. It's not an ICBM. ICBMs go further. Intermediate range, intercontinental. That's the difference, right? So bumper is an IRBM. The bumper program led to the Redstone program, also an IRBM. And then the Jupiter C, and then the Juno, also intermediate range. Okay? Here's the thing. Everybody's like, oh, we lifted all of our rocket tech from the Germans. That's totally not true at all. The rocket tech that we used to get to the moon, inadvertently, yeah. I would argue that not a lot of rocket technology from the Nazis we ended up using. We used the guy that made him. The guy that made them. That's the difference. Not the tech. Von Braun could project manage like a mother trucker. How do I know? I've talked to guys that worked for him before. I've talked to guys that worked for him on stream. They called him the leader for a very good reason. He was a great project manager. He was the best. Like the best. He single-handedly managed the entire Apollo program. Think about that for a second. Okay. So the interesting thing is that completely agnostic to, the Redstone, Jupiter C, Juno, right? Which was the Army's missile program. The Air Force and Convair were working on 2 other programs, Titan and Atlas. Okay, you guys want to hear something nuts? The first designs for SM-25 for the original Atlas was 1954. Convair was working on it in literally less than a decade after World War II. Pretty crazy, right? The earliest ICBM skeleton, Atlas, Titan. Titan came a little bit later, but that's another story. Well, Titan 2 came a little bit later. Atlas, Titan 1, even Redstone, IRBMs, right? Those were all liquid fuel because there wasn't anything better. They hadn't really figured out solid fuel yet. Solid fuel existed as rockets that shot out of airplanes that, like for a rocket munition, right? Somebody put 2 and 2 together and said, hey, why don't we just make that bigger? Oh, it's a good idea. But a lot of the first rockets, right? A lot of the first ICBMs and IRBMs that the U.S. carried, so Thor, Redstone, Jupiter, Juno, Jupiter C, Atlas, Titan, they were all liquid fuel. Atlas particularly used liquid oxygen. And what they really quickly figured out is that if the rocket, they ordered a bunch of those. They were like, oh, this technology is amazing. This is great. We need more of this, right? They ordered a ton of them because it's the Cold War and you don't... What? What? So, here's Titan. Okay. Thank you. I'll see you later. She said we heard you were talking about Titans. Okay. So those first ICBMs were made with locks, and then they figured out that if the rocket takes 30 minutes to fuel up, right? And somebody launches a nuke at you, it's going to take 15 minutes to get here, and the rocket's going to take 30 minutes to go. It's not really a good idea. We probably shouldn't do that. So they looked into other things. Where they went from there was Titan 2. Because not a lot of people know that Titan 1 was kerosene in liquid oxygen. Titan 1 missiles did not use hypergulls. Titan 2 missiles did. The reason why they were able to switch from Kerolox to hypergolic is because the LR-87 and the LR-91s use gearboxes to drive their pumps. If you use a gearbox to drive the damn pump, change the gear ratio, and you can easily run a different propellant. Deliver the right amount of fuel in the right proportions, and you're good to go. The LR-87, Titan 2, or the Titan 2 engine, the LR-87 and the LR-91 in the upper stage. Those are the LR-87 in particularly. I can't speak to the LR-91 to be 100% honest with you. But the LR-87 is one of the only rocket engines in existence to run off kerosene, hydrogen, and monomethyl hydrazine. You can run off all of them. You could do any one. So with Titan II, they changed the gear ratio and they switched to hypergalls. Hypergalls were seen as a much better thing. It's a much better opinion. It's a much better thing, right? Because hypergalls, you could just keep the rocket fueled all the time. Right? It's a really good idea. And just keep it fueled. It's fine. Just keep it fueled all the time. And you're good to go. And then they realized that, if keeping a fully fueled rocket inside of a silo is a little bit dangerous with liquid fuel propellants. That's especially if it's hypergalls, because with hypergalls, you can't get near it if you need to do maintenance on it. The rocket's fully fueled. So say you got to go tighten a bolt or something. You are doing maintenance in a escape suit, basically a space suit that has like filters so you don't breathe in NTO or MMH, the fuels for it, because they'll kill you if you breathe it. And you're doing maintenance on a fully fueled vehicle. That's probably not smart. So by the time the 70s came around, they kept Titan as a retaliatory strike weapon into the 80s, right? The Titan missile was good if you needed to pack a punch because it's a pretty heavy duty lifter for an ICBM. Titan would be like using Falcon 9 for an ICBM. I mean, yeah, you could. You don't need a rocket that big to deliver the boom booms, but that's another story, right? So they eventually switched to solids because solids you can keep in there. They're easy to do maintenance on. Yeah, you got to be careful. You don't want to ignite the propellants, right? But also you don't have to wear a spacesuit and basically Mickey Mouse gloves every time you go to do maintenance on the thing. So they eventually moved to solids. And the leftover stock from all of these missiles, from Titan 1, from Titan 2, from Atlas, right? Atlas D, Atlas E, and Atlas F, because they ordered a lot of those things. Here, you want to see? Here, you want to see something pretty cool? When I say they ordered a lot of those things, I mean they ordered a lot of those things. Don't tell me that rockets can't be mass produced, because also that was 60 years ago. And thus Minuteman? Yeah, Minuteman 1, Minuteman 2, Polaris from the Navy, and then they went into a bunch of other different designs, like the MX Peacekeeper and a bunch of other things. Titan II carried 9 megaton warheads, the W-53. That is a lot of canned heat. That's right. That's right, Nader. The Damascus incident basically demonstrated why you don't want to leave a fully fueled hypergolic vehicle sitting in a silo. That's probably not a good idea. Some guy dropped a wrench when he was doing work on the thing, right? And it punctured the tank and started leaking hypergalls everywhere. That ended about as good as you think it does. Yeah. The Damascus incident, not great. Not great. Minutemen is solids. They're all solid rockets. TARS, that's pretty funny. So, yeah, dude, the early ICBMs were all liquid fueled. And then they realized that liquid fuel vehicles make better, liquid fuel vehicles make better orbital launch vehicles, right? And that's when you started to see the divergence. Tridents are solid. Yeah, Tridents replaced... No, I don't know that for sure. I was going to say they replaced Polaris, but that doesn't sound right, John. You would know better than I do. I defer to your judgment. But there was no casualties, if I remember well. Yeah, TARS, but, there's that whole hypergolic fumes just leaking everywhere. It's not exactly... They didn't exactly advertise where the Titan II missile silos were at the time. So, you imagine you're driving down the road in, what is it, Arkansas, and You just see a big orange cloud coming from a farm. Yeah, it's probably not great. You oil these up properly and you're good for maintenance for a couple of years. That's right. That's right, Alex. Do you know what they oiled them up with? Water displacement formula 40 was invented to keep condensation from happening on the outside of an Atlas missile. WD-40. Yep, that's what it was invented for. Pretty cool, huh? Yeah, just as an additional thing. I think that's pretty neat. No clue, but it always confounded me how a missile launched from a mobile platform with just solid fuel could hit targets with precision. They're good at what they do, man. Good at what they do. Just saying. WD-40 is not a lubricant. It is a water displacement formula. PB Blaster or air tool lubricant. Yep, John, they're just good at what they do, man. Is there going to be a new ICBM for the United States in the coming years to replace the Minutemen? I would say probably yes. I don't know. I don't really keep up with ICBM stuff. The only real knowledge of ICBMs that I really know is from the early days, because there's convergence there with launch vehicles. I know launch vehicles way better than I know ICBMs. That, and I really don't, like, it's one of those things. I don't really want to go and Google ICBM technology. Like, I don't want to type that into Google in this day and age. I don't want to do that. I don't want to do that at all. I don't think that's a good idea. We probably shouldn't do that. So I kind of just, ICBM tech is over there, and it's just not near here. Do you think in my line of work, it's probably a wise decision, right? Like, that's probably a good idea. Probably shouldn't. You know what? That's Pandora's box, and I'm just going to keep it closed. I'm just going to put it over there. They're very precise. Yep. I just closed 3 tabs. Thanks for the reality check. Snibbles. Yeah. You probably, it's probably, I could probably figure it out, but I'm not doing that. I'm not going to do that at all. Let's just talk about the stuff that goes into space and stays there. The only stuff I want coming back down from space is capsules and spaceships, space planes. Okay, that's the re-entry vehicle I want to talk about. Yeah, Hunster. I don't know. I don't know. I can't guarantee that. You just never know in this day and age. I don't want to talk about that. I don't know what you mean. I don't know. I don't record these events at this time. Oh boy. No. Okay, another thing here, check this out. We got a new Shepard launch on the books for Sunday, which is pretty cool, NS-34. Blue's really hitting pace with the new Shepard rocket, guys. I'm actually pretty impressed. They've been, they're launching to the tune, I believe it's once a month. That's pretty damn good. Pretty good scale. The Minuteman 3 is accurate within 200 meters of its aim point. You're not going War Thunder forums on me right now, Nader, right? That's the claimed accuracy. See, guys, here's the thing. All right. Here's the thing. It's a nuke. I don't think it needs to be like superbly accurate. Like, you don't need like sub-centimeter precision like that with a nuke. You know why? Like, yeah, LMC, 200 meters is good enough. Yeah, that's good enough. I'm pretty sure that's going to accomplish your goal of getting rid of whatever you needed to get rid of, you know? Like, if we're going to think about it logically, right? You know, 200 meters with a 300 kiloton warhead, yeah, that's fine. That's good enough. I'm pretty sure it doesn't need to be more precise. We can't deny it. New Shepard seems to be a success. I wouldn't have bet in it. Right, Tars? I'm kind of with you on that one, dude. Good for them, man. I'm super happy for them. I'm dead serious. That's great. Scaling any rocket program is difficult. Let alone a rocket that has people riding on it. That's hard to do, man. I give them credit. Credit where credit is due. That's pretty good. The other thing I wanted to show you guys is actually over here. Check this out. Check this out. Creeper, where are you? I know you wanted to see this. Look. Blue posted this. Keeping it cool. Our lunar permanence team is testing zero boil-off technology to store liquid propellants at extremely low temperatures for Blue Origin's lunar missions. We have successfully met all NASA test objectives, demonstrating our ability to make liquid hydrogen and liquid oxygen in space storable propellants at 2 times the performance of the current state-of-the-art. The system is key to fueling our Blue Moon Mark II lander, which will ultimately deliver astronauts to the moon. I'm going to add that to the Flame Trench show notes. So, Blue Origin demonstrates zero boil off tech. Go. Flame Trench talking point. I added it into the other things part of Flame Trench. The topics that we have going right now are the Eris-1 launch failure, Crew 11 launch, and X-37B. And then Starship, obviously. I haven't filled out the Starship news yet because nothing has happened except Ship 37 and moved. And Ship 38, right? Blue Moon is going to be done way before Starship HLS at this rate. Yeah, Cheeseburger, there's no doubt that Blue is making strides. There's just one problem. You're going to need a lot of new blends. Where are those at? Genuine question. I'm not saying they don't have them. I'm saying, look, it's been 7 months. 7 months since the last New Glenn launch. Blue at the end of that New Glenn stream, I remember exactly what Ariane Cornell said, that they have another one ready to go and they'll be ready to go sooner rather than later. Well, dude, that was 7 months ago. Where is it at? Blue might make, what I'm telling you is that Blue might make the damn lander and not have a way to get it into space. SpaceX might make the launch vehicle, right? SpaceX might make the lander and launch it into space and it might not be able to go any further. When their powers combine, they form one fully functioning lunar architecture. Just saw that the Minuteman 3 has an updated inertial guidance system that has dropped its error to 120. Nice. They had to recover from their bumps being fisted. Yeah, certainly that preparation age. So the next thing here, we got an update from Project Kuiper. Our next mission is set for Net Thursday, August 7th, designated KFO2, our second launch on the SpaceX Falcon 9 rocket. The mission will send 24 Project Kuiper satellites into low Earth orbit. So let's check our manifestivo here. What do we got? What do we got for the rest of the week? So we have Crew 11 tomorrow. Actually, you know what I wanted to check out? When does coverage start on that? Launch coverage. Oh, here it is. This is right off of NASA's website. Live launch day coverage of the Crew 11 launch will begin Thursday, July 31st at 8 a.m. Eastern on NASA Plus, Netflix, and Amazon. I don't have a problem with it. I guess it's just yeah. 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 NASA's TV should be like C-SPAN. It should be like C-SPAN. Everyone should carry it, and everyone should be able to have access to it, okay? It should be like C-SPAN. Comes with every single cable package. Every single thing, every single television subscription should be like C-SPAN. This is ridiculous. Like it was back in the day. It should be easily accessible. Everybody should be able to, you shouldn't need Netflix and Amazon Prime to do that. That and NASA Plus is stupid, and I want to slap whoever came up with it in Minecraft. It's on YouTube. Cool, that's fine. He said don't link YouTube. You can link YouTube. I was just doing that because I said that because I was pissed, I know. I hate it. Like, dude, I have snafus on stream all the time. I hate ads. And I hate it when I have to play ads for you that you don't deserve to hear, okay? I hate them so much. I hate them so much. It's straight overstimulation. And we wonder why kids are so goddamn cooked nowadays. We wonder why. Hold on, you piece of shit. Retrieved ad time, you jackass. We wonder why kids love brain rot and stuff. It's just in TikTok. It's just straight overstimulation, man. These kids are gonna come out cooked, man. They're gonna come out fried, like straight fried, dude. That bothers me. It bothers me a lot. That's why I don't like ads. That's the reason. I will make less money. I'm totally cool with that. Totally cool. It's just, it's so bad, dude. Like at every dude, my job's on the internet. It's on the internet. I'm on the internet a lot. At every waking moment. There's not a single moment where someone is not trying to sell you something or steal your data to make money off of. It is ridiculous. It's turned into such a free-for-all. It just sometimes makes going on the internet just painful. It makes me want to go outside. Okay? Back in my day, in the early 2000s, when I was in high school, I could spend all day on the internet. It was amazing. I was like, outside? No, son. No, we don't do that. We don't do that here. No, now I'm like, this is so bad. I need to go outside. I'm just gonna go outside and stare at dirt. Ads on YouTube are so bad. Crowd, Nick, you tell me about it, man. Freaking minute unskippable ads, like 5 in a row. What happened when Susan Wojcicki a little while back was like, we're gonna make it 2 and it's gonna stay like that. No, it's like 8 now. How many goddamn insurance commercials do I need to watch? See, another one of those with that stupid ostrich and that stupid moron with that duster that I want, the yellow duster. I'm gonna slap somebody. Anyway. Slap that damn ostrich. You want ad for YouTube? No. I get it. You need to run ads. I understand. Yeah, whatever. It's gotten, what I'm trying to tell you, like, dude, I understand people got to make money. I get it. What I'm trying to tell you is that it's gotten so ridiculously bad for me. There's times where, like, I click on a YouTube video and the ads are so bad, I'm just like, I don't feel like watching this anymore. I'm going to do something else. Bye. Shut the TV off and walk away. It's an emu. I was disparaging it by calling it the wrong species of bird. Did you guys not pick up on that? Okay, I'll lay it on thicker next time. Frick them birds. Michael Jordan. Anyway, yeah, guys, I got to get up at 7 tomorrow. I stopped paying attention a while ago. Thanks. Appreciate it. Trying to be funny. Trying to make your day a little bit brighter by having a fun, hilarious rant about how EJ hates birds and ads. I guess you're not amused by it. You know, you could just say, you know, a simple wrong could have done just fine, but you know, that works too. I tend to mute YouTube ads. Dude, it gets so bad. I just shut the TV off. I go into my shop. I go and sit in my shop and do something else. Wait, did you see the India NASA launch? Israel launched something, yeah. What is that about? I'm not familiar. So this is GSLV F-16. All right, what do we got here?
Seven, 6, 5, 4, 3, 2, 1, 0. All L40 engines generating nominal thrust. S139 motor ignited. 5 seconds.
That's a magnificent of the GSLV F-16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जहाँ अभी आपने देखा चारों L40 तथा 4 बूस्टर S139 का सफल प्रज्वलन और GSLV
This is not live now.
उत्थापन द्वितीय प्रमोचन मंच से और ये अपने गंतव्य की ओर बढ़ता हुआ
7.
Cool. So what version of that? That was geostationary satellite launch vehicle F-16. That's cool. That was carrying a NASA ISRO joint NISAR mission. Cool. All right, that's pretty neat. Sweet. Good stuff. What else do we have on the launch manifest? That's not Crew 11. No. Okay, cool. There's a Falcon. Oh, what the hell? Tweaky, did you see the F-18 Spain Air Show near miss bird strike? Yeah, I've seen it, dude. I didn't realize it was a bird strike when I showed it, and I was like, I'm not sure what was going on there, but the guy actually was avoiding birds. Yeah, so Starlink 13-4 is going to launch a half hour after the crew's on orbit, man. All right, tomorrow's going to be a long day. It wasn't a bird strike, dude. Zonku, I saw a camera angle of the F-18, like it was from the front looking at the F-18 coming towards, and there are actually two birds, and the guy, when he turned, he split the difference. He didn't hit a bird. He avoided them. The pilot saw him. So it's actually like, not like the pilot has no idea what he's doing. The guy that was flying that plane saw them. He saw the freaking things, and he maneuvered around them. Yeah, it was close. It was real close. But, yeah. And then he recovered. Yeah, dude, fucker moment. I mean, honestly, that's pretty damn good situational awareness, right? The guy knew doing a maneuver like that, he had the altitude to do it. You do not want to risk a bird strike, right? Because if you do, you're coming down with everybody watching you. You're coming down in a populated area if something goes wrong, right? What happens if you have to eject? You're going to eject, your plane's going to fly into a building. No, that was absolutely the right move. That dude, that Spanish pilot that was flying that plane knew what's up. That's really smart, man. That's really, really damn good situational awareness. And that's one of like the biggest things of being a pilot, especially a fighter pilot in general. You really have to understand what's going on. There can't be an unknown unknown when you're flying. Because when unknown unknowns happen, it usually ends up with you crashing. You really have to be aware of where are your surroundings. Given the angle and the speed, it would have gone straight into the beach or beyond into the buildings. Yeah, that guy made that decision that quickly. He made that decision that fast, split second. What do? You have less than a second to respond. Do you just try to fly it, or try to maneuver around the birds, knowing you could crash? Or do you crash and try to risk the bird strike? Frick that. No fun. Bad. I would, I'm not saying I would have done the same thing. I probably wouldn't have seen it and slammed right into the birds, like that's why that guy's flying an F-18 and I fly F-18s in Kerbal. Okay. All right. What else we got for the rest of the week? That's it. Just Crew 11. Good stuff. All right. So that's going to do it for Space News. I hope you guys enjoyed it. How are we going to do this? I want to play Summer Car. Everyone was asking me, a bunch of viewers asked me if I was going to play Summer Car tonight. And I was like, yeah, of course I'm playing Summer Car tonight. I forgot what day it was. Your brain is so fried. Yeah, it's from all the ads. How are we going to do this? Today's Wednesday. Stuart, I was wondering okay. Stuart in chat was one of the viewers that asked me that. Were you asking me that because of the Crew 11 coverage? See, Tessa, I got a little bit of a problem, though. I slated Thursday and Friday because it's going to rain tomorrow. And it's going to be cooler in the shop as car stream days. We have to finish our Hearts of Iron playthrough, where I'm probably going to get railed by the Allies, so that's fun. We got to play Summer Car this week, too. And we have to finish working on the damn rocket in Kerbal. I was asking you because I knew Hearts could take a long time. Oh, okay, cool. So, how do we do this? I really should get some sleep. And then tomorrow, I don't think we'll have time to work on the car. Tomorrow, we'll do the crew coverage, right? That's going to take from 8 to about 1 p.m., right? And then we could finish our Hearts save after that, and then do space news after that, and then Summer Car. That's going to be like a 16-hour stream. I can do it. I just need a good night's sleep to do it. And then we could work on the car on Friday. And we could work on the car on Friday and play Kerbal. Work on the car in the morning on Friday and play Kerbal before Flame Trench. And then we have a huge race at Road America. Oh my goodness, the next 2 days I'm booked solid. In the next 2 days, I'm going to like work 32 hours. All right. Sounds like fun. I gotta go. I got 3 hours of sleep last night. I have to go, and I have to prepare. I wanted to play Summer Car tonight, but now that I'm thinking about it, now that I really got my bearings, that is a really bad idea. I gotta go.
Go and throttle up.
He's in Tier 2 94-month resub. Don't dial 911, dial 357. Ammunition. Protecting your rights. Nothing in comparison to COVID streams, that's right. Dude, I still don't know how I did those, Snake. I just don't know how that happened. Okay, so the next 2 days are going to be basically 16-hour streams. Thursday, Friday. I have a meeting tomorrow, too. At 11. Yeah. I'm gonna go sleep. I'm going to bed. I'm going to bed. You're digging the Polish Smash? Can't see me? All right. You'll see more of that tomorrow after the crew coverage. Oh my goodness. Oh my goodness. I just realized the colossal screw up that I just ran into. Paramedic Pets! Glad I caught you. Great to see you again. So, Paramedic, before I leave, are you sticking around or what? Are you back, or was this just a one-time thing? If you're back, that's cool, man. If not, I'll see you again in 5 years. You did this to yourself. Yeah, that's right. I did. Not sure what life will bring. Yeah, I do. Like, I just realized that my next 2 shifts are 16 hours long. Yeah, that's great. That's just... What am I doing? All right. Is it a meeting with Yank? No, I wish. All right. On the Twitch side of things, let's raid. Who are we raiding? Ooh, Etal just started up. I'm going to fall asleep to an Etal RimWorld stream. Let's go see what he's up to, guys. Next 2 days are going to be crazy. I'm going to go get some rest. I'm going to need to do that a lot. Go see what Etel's up to on YouTube. I'll see you guys tomorrow, 8 a.m. Crew 8. 8 a.m. for Crew 11 launch coverage. Have a good night, everybody. I'll see you. Go raid Etel.